Or what if time itself is broken? Tonight, we journey through paradoxes that defy logic and reality. Stay with us. This is a ride into eternity you won't forget. Hit play, relax, and let's fall into the mysteries of time together. Retroactive suicide paradox. There's a letter on your desk, your handwriting, but you didn't write it. It describes, in perfect detail, your death tomorrow at 3:47 p.m. A car accident on 5th Street. The blue sedan running the red light. The exact angle of impact. The letter is dated next week, signed by you, and at the bottom, a single line. I came back to warn myself, but I'm beginning to realize that might have been the mistake that causes everything. Tonight, we're exploring the darkest of all temporal paradoxes, the retroactive suicide paradox, where attempting to prevent your own death becomes the very thing that causes it, where knowledge of the future doesn't empower you, but imprisons you in an inescapable loop of causality that ends with your own termination. This isn't about grandfather paradoxes or butterfly effects. This is about the mathematical impossibility of using time travel for self-preservation. Every equation that allows backward time travel also predicts that using it to save yourself might be the most dangerous thing you could possibly do. Consider the logic. You're going to die tomorrow. Future, you knows this because they lived it, experienced it, died from it. But somehow they survive long enough or find a way to send information back, a warning, details, everything you need to avoid that fate. You receive the message. You stay home. You avoid 5th Street. The blue sedan crashes into empty air. You've won. But have you? If you don't die, you never send the warning. If you never send the warning, you don't know to avoid 5th Street. If you don't know to avoid it, you die. If you die, you send the warning. The loop collapses into paradox, and the universe has to resolve it somehow. Scientists who study closed time-like curves have discovered something disturbing. The mathematics suggests that the universe might resolve such paradoxes through what they call the Novikov self-consistency principle. Events arrange themselves to prevent paradoxes, but here's the horror. Sometimes the only consistent solution is the one where you die. Think about it geometrically. Time travel creates a 4-dimensional loop in space-time. That loop has to be consistent. Every event on the loop must lead to the next event on the loop. If your death is part of that loop, then your death becomes geometrically necessary. The universe will conspire to kill you, not out of malice, but out of mathematical necessity. Let me tell you about an experiment that was never officially published. In 1997, a quantum physicist claimed to have sent information backward through time using quantum entanglement. Just a few bits. Binary code. The message was simple. Danger stop. He received it 3 days before sending it. He didn't know what danger to stop, so he continued his experiment. 3 days later, his equipment malfunctioned catastrophically. In the hospital, dying from radiation exposure, he managed to send one message back. Danger stop. The loop was closed. His attempt to warn himself became the very thing he was warning himself about. The paradox resolved itself through his death. This is the retroactive suicide paradox in its purest form. The warning creates the danger. The prevention causes the event. The cure becomes the disease. It's not that you can't change the past. It's that changing the past might require your death as payment. The paradox becomes more insidious when you consider partial information. You receive a warning from the future. Don't go outside on Tuesday. You stay inside. But because you stayed inside, you never learn what the danger was. Was it real? Was it a mistake? You'll never know. But future, you must have had a reason to send it. So you send the same warning back, just to be safe. The loop closes. You're trapped inside every Tuesday forever, prisoner of a danger that might not exist. But here's where it gets worse. What if the danger only exists because you avoided it? By staying inside, you cause a gas leak you would have noticed if you'd left. The explosion that kills you happens because you tried to avoid death. Your future self, dying in the flames, sends back the warning that causes the flames. The universe ensures its own consistency through your termination. Quantum physicists have noticed something they call the chronology protection conjecture. The universe seems to prevent paradoxes through increasingly improbable coincidences. Try to kill your grandfather and the gun jams. Try again and you miss. Try 1,000 times and 1,000 unlikely events prevent you. But these preventions follow the path of least resistance. And sometimes the path of least resistance is your death. Imagine you discover proof that you'll die in 30 years. Old age. Natural causes. You could accept it, live those 30 years, die on schedule. The loop is consistent, but you don't accept it. You exercise obsessively. You take every supplement. You undergo every treatment. You're determined to live longer. The universe now has a problem. You're supposed to die in 30 years, but you're taking actions that might prevent it. The loop is becoming inconsistent. So the universe responds. That exercise routine causes a heart defect. Those supplements interact badly. Those treatments have unexpected side effects. The harder you try to avoid your death, the more certain it becomes. Your very attempt to escape becomes the cage. This has implications for free will that make philosophers nauseous. If you receive information from the future about your death, are you free to avoid it? Or does the receipt of that information lock you into a causal chain that ensures it happens? The knowledge itself might be the trap. Ignorance isn't bliss, it's freedom. Consider the tourist paradox. You travel forward in time to see how you die. You witness it. Now you return to your present with that knowledge. But the future you visited was one where you had that knowledge. Your death already incorporates your attempt to avoid it. You didn't see how you would have died. You saw how you will die despite knowing how you will die. The mathematics of this are brutal. In a universe with time travel, every possible death becomes a potential fixed point in space-time, a necessary event that cannot be avoided because avoiding it would create paradox. The universe doesn't care about your survival. It cares about consistency. And if your death is necessary for consistency, then your death becomes as certain as gravity. Some physicists propose that consciousness might be the key. They suggest that you can't actually travel back before your own birth or forward past your own death. Your consciousness creates a barrier, a temporal prison cell with your lifespan as the walls. Try to break out, and reality itself stops you. The ultimate temporal claustrophobia. But there's an even darker possibility. What if you can travel past your death, but doing so causes it? The moment you observe a future where you don't exist, you create a causal requirement for your non-existence. Your observation of your absence makes your absence necessary. You've committed retroactive suicide just by looking. The paradox appears in quantum mechanics as well. There's something called the quantum suicide thought experiment. In many worlds, interpretation, you're constantly splitting into parallel universes. In some, you die. In others, you survive. But you can only observe the universes where you survive. This creates a form of quantum immortality, where your consciousness always follows the path where you live. But time travel breaks this. If you can send information between parallel universes, you can inform versions of yourself about their upcoming deaths. This knowledge might collapse the quantum superposition, forcing all versions into the deadly outcome. The mere possibility of warning yourself might kill every version of you across all timelines. Real experiments have shown disturbing hints of this. Quantum systems that receive information about their future states tend to collapse into those states. It's called the quantum Zeno effect. Observation freezes outcomes. Knowledge creates destiny. Information becomes fate. Think about what this means for prophecy. Every prediction of death might be self-fulfilling, not through psychology, but through physics. The oracle who predicts your doom might be creating it through retroactive causality. The fortune teller who sees death in your future might be inserting it there. Knowledge of death becomes death itself. The retroactive suicide paradox suggests that time travel might be the universe's perfect murder weapon. Send someone information about their future death, and you've potentially killed them. Not in the future, but retroactively, across all of time. Their entire timeline becomes a trajectory toward that revealed moment. Every choice they make, even choices intended to avoid it, become part of the path that leads to it. And here's the ultimate horror. We might all be receiving such information constantly. Every premonition of danger, every fear of death, every anxiety about the future might be a message from our dying selves. We dismiss them as paranoia, but what if they're warnings? Warnings that, by their very nature, ensure the deaths they're warning us about. That dream where you die. Maybe that's not imagination, but information, leaking backward through time from the moment it happens. That sudden certainty that something bad is about to occur. Maybe that's your future self, desperately trying to warn you, not knowing that the warning itself is what causes it. The retroactive suicide paradox reveals the cruelest truth about time travel. It's not a path to immortality, but to inevitable mortality. Every attempt to use it for survival might decrease your chances of survival. The power to know the future might be the curse that destroys it. Tomorrow, you might receive a message, a warning, information about your future that seems designed to help you. But remember this, in a universe where time travel is possible, every warning might be a weapon, every prophecy a poison, every glimpse of the future a trap that makes that future inescapable. The letter on your desk, the one describing your death tomorrow at 3:47 p.m., you have three choices: ignore it and die because you ignored it, believe it and die because you believed it, or destroy it and die because you destroyed it. The paradox doesn't care which you choose. All paths lead to 5th Street. All choices lead to 347. All timelines lead to that blue sedan. Unless, of course, the real paradox is that the letter is lying, that there is no danger, that the only threat is the letter itself, sent by a version of you who went mad from receiving a similar letter, trapped in an infinite loop of false warnings that create real deaths. But you'll never know which is true. And that uncertainty, that horrible doubt, might be the very thing that drives you to 5th Street tomorrow at 3:47 p.m. just to see if fate can be changed, just to test if the future is fixed, just to know if the letter was real. And in that moment of impact, in that final second of consciousness, you'll understand why you had to send the letter back. Not to save yourself, but to complete the loop, to close the circle, to ensure that the past happens exactly as it must for the future to exist, even though that future is your death. The paradox isn't that you can't save yourself. It's that saving yourself might require accepting your death, and accepting your death might be the only way to truly die. Butterfly effect paradox. In 1952, Ray Bradbury wrote a story that would haunt the dreams of physicists for generations to come. A hunter travels back to the age of dinosaurs, steps off the designated path for just a moment, and crushes a single butterfly beneath his boot. When he returns to his present, the world has changed. Language is different. The wrong candidate has won an election. Reality itself has been rewritten by the death of one insignificant insect 65 million years ago. But here's what Bradbury didn't know when he wrote that story. He had accidentally stumbled upon one of the most profound paradoxes in theoretical physics. A paradox that suggests time travel might not just be dangerous, but logically impossible. Tonight, we're going deep into the butterfly effect paradox, where mathematics meets madness, and where the smallest change can unravel everything. Let me take you back to 1961. Edward Lorenz, a meteorologist at MIT, is running weather simulations on a primitive computer. He wants to rerun a particular simulation, so he types in the numbers from his previous printout. But to save time, he rounds one number from 0.506127 to 0.506. A difference of 0.00127, practically nothing. A rounding error, insignificant. The simulation should have produced nearly identical results. Instead, after just a few minutes of simulated time, the weather patterns diverged completely. Where the original showed clear skies, the new simulation showed storms. Where there had been high pressure, now there was low. The tiny change had cascaded through the system, amplifying with each iteration until two completely different realities emerged from nearly identical starting points. Lorenz had discovered what would become known as sensitive dependence on initial conditions. In complex systems, microscopic changes create macroscopic consequences. He would later give a talk asking whether the flap of a butterfly's wings in Brazil could set off a tornado in Texas. The butterfly effect was born. Now, let's apply this to time travel. Imagine you've built a time machine. You step into it and travel back exactly 100 years. The moment you materialize in the past, before you've even taken a step or spoken a word, you've already changed everything. Your body has displaced approximately 70 liters of air that would have been in that exact spot. Those air molecules now have to go somewhere else. They bump into other molecules, which bump into others, creating a cascade of molecular collisions that wouldn't have happened. The temperature of your body, roughly 37 degrees Celsius, adds heat to the local environment. That heat changes air pressure, however slightly. Changed air pressure affects wind patterns. Changed wind patterns affect weather systems, but it goes deeper. Your breathing. Every breath you take removes oxygen molecules that would have been breathed by someone or something else. Every exhalation adds carbon dioxide that wasn't there before. The bacteria living on your skin, in your gut, in your lungs, are now interacting with the bacterial ecosystem of a century ago. Some will die, some will thrive, some will mutate. Your mass, roughly 70 kilograms if you're an average adult, exerts gravitational force on every particle around you. It's tiny, almost immeasurable, but it's there. Every atom in the past is now being pulled slightly differently than it would have been. Even the photons bouncing off your body are following different paths, carrying different information to different observers. In chaos theory, there's something called the Lyapunov time. It's the timescale on which a dynamical system becomes unpredictable. For weather systems, the Lyapunov time is about 5 days. This means that an uncertainty the size of a molecule will grow to the size of a weather system in just 5 days. Within 2 weeks, molecular level changes can affect global weather patterns. But humans aren't just affected by weather. We're affected by everything. That person who would have breathed the oxygen molecule you just inhaled, their blood oxygen level is now different by 1 molecule. Insignificant? Their brain chemistry is slightly altered. Neurons fire a nanosecond differently. They blink at a slightly different moment. They miss seeing something they would have seen, or see something they would have missed. Maybe they don't notice an attractive stranger across the street. They don't smile. That stranger doesn't feel encouraged to start a conversation with someone else. A relationship doesn't form. A child is never born. That child would have grown up to inspire someone to become a scientist. That scientist would have made a breakthrough. Without that breakthrough, technology develops differently. The future changes. Or maybe it's simpler. You appear in 1924. A horse sees you materialize and gets spooked. It runs slightly to the left instead of slightly to the right. Its hoof lands on slightly different ground. Over the next month, this creates a tiny change in the erosion pattern of the road. When it rains, water pools slightly differently. Someone's Model T Ford hits that puddle at just the wrong angle. They skid. They're delayed by 5 minutes fixing a flat tire. Those 5 minutes mean they arrive at their destination after someone else has left, instead of before. They never meet. A business deal doesn't happen. A company never forms. Thousands of jobs that would have existed don't. Different people meet different people. Different children are born. Within a generation, almost no one who would have existed in your original timeline exists anymore. The mathematics are terrifying in their implications. Scientists have calculated that in a typical chaotic system, uncertainties double approximately every few days. Start with a change at the molecular level, practically unmeasurable. After a week, it's affected things at the millimeter scale. After 2 weeks, the centimeter scale. After a month, the meter scale. After 2 months, the kilometer scale. After a year, continental scale. After a decade, global scale. But here's where the paradox truly emerges. If your presence in the past changes things this dramatically, then the future you came from never happens. The exact sequence of events that led to your birth gets disrupted. Your parents might never meet. Even if they do meet, they meet under different circumstances. They have children at different times. Different sperm meets different egg. You're never born. But if you're never born, you never travel back in time, which means you never change the past, which means you are born, which means you do travel back in time, which means you're not born. We're trapped in a logical contradiction with no resolution. Scientists have proposed several solutions to this paradox, each more mind-bending than the last. The Novikov self-consistency principle suggests that the universe somehow prevents paradoxes. You can travel to the past, but only in ways that were always part of history. Every change you try to make either fails or was always supposed to happen. The butterfly you step on was always meant to be stepped on by a time traveler. Your presence was already woven into the fabric of history. But this solution has disturbing implications. It suggests that free will might be an illusion, at least for time travelers. The universe becomes a kind of four-dimensional crystalline structure where past, present, and future are equally fixed. You can no more change the past than you can change the present by willing it to be different. Then there's the multiple timelines interpretation. Every change you make creates a new branch of reality. The moment you arrive in the past, you've split off a new timeline. The butterfly you kill creates a universe where that butterfly died, while your original timeline continues unchanged, somewhere else in the quantum multiverse. You can never return home. You're doomed to live out your life in a universe you've created, orphaned from your own history. This solution preserves free will, but at a terrible cost. It means that time travel is essentially a one-way trip to another dimension. You're not really traveling through time so much as you're creating new realities and abandoning old ones. Some physicists have proposed the chronology protection conjecture, the idea that the laws of physics somehow prevent time travel from occurring in the first place. Maybe the energy requirements become infinite as you approach a closed time-like curve. Maybe quantum fluctuations destroy any would-be time machine. Maybe the universe has built-in safeguards we haven't discovered yet. But perhaps the most unsettling possibility is that we're already living in an altered timeline. What if time travelers have already been here, have already made their changes, and we simply can't know because this is the only reality we've ever experienced? Every moment of history we think we know could be the result of countless temporal interventions. Butterflies crushed and released. Changes upon changes upon changes until the original timeline, if there ever was one, is lost forever. Think about the times when reality feels slightly wrong. Déjà vu, the Mandela effect. Moments when you could swear something happened differently than everyone else remembers. What if these aren't failures of memory but glimpses of timelines that no longer exist? Ghost echoes of futures that were supposed to be but never will be, because someone, somewhere, somewhen, stepped on a butterfly. The butterfly effect paradox forces us to confront the fragility of causality itself. In a universe where time travel is possible, cause and effect become scrambled. Events cause their own prevention. Effects precede causes. The simple linear story we tell ourselves about reality breaks down into quantum foam and temporal chaos. Consider this. Right now, as you listen to these words, countless butterflies are flapping their wings around the world. Each flap sends out tiny ripples through the atmosphere. Those ripples interact, interfere, amplify, and cancel. They contribute to weather patterns that will affect human decisions that will shape history. In a very real sense, the future of humanity depends on the butterflies. Now imagine that among all those butterflies, one of them, just one, was stepped on by a time traveler from our future, or saved by one. How would we know? How could we ever know? The timeline we're experiencing might be the result of that one crushed or saved butterfly, and we'd have no way to detect it because we have no access to the timeline that would have been. This is the true horror of the butterfly effect paradox. It's not just that time travel might change history. It's that we might never know if history has been changed. We could be living in the ruins of countless collapsed timelines, in a reality that's been edited and re-edited by temporal interference until nothing remains of the original, but quantum echoes and half-remembered dreams. The next time you see a butterfly, watch it carefully. Notice how its wings create tiny vortices in the air, how those vortices spiral outward and dissipate. Consider that those microscopic air currents will interact with billions of other air currents, contributing to weather patterns that will influence human events that will shape the future. That butterfly, in its small way, is writing history. And if someday, someone from our future travels back to this moment, their first breath will rewrite everything. The butterfly's wings will beat differently. The vortices will spiral in new directions. And the future, your future, my future, will become something else entirely. Something unpredictable. Something that was never supposed to be. Unless, of course, it was always supposed to be this way. Unless that time traveler's breath was always part of history. Unless we're living in a universe where every paradox resolves itself, where every change was always meant to happen, where free will is an illusion and the future reaches back to create itself. Observer's paradox. The year is 1935. Erwin Schrödinger is arguing with Albert Einstein about the nature of reality. To make his point, Schrödinger describes a thought experiment, a cat in a box with a vial of poison that will break based on radioactive decay. Until someone opens the box, quantum mechanics says the cat is both alive and dead simultaneously. Einstein hates this idea. He refuses to believe the universe works this way. But here's what neither of them fully grasped at the time. They had stumbled onto something that would become even more disturbing when applied to time travel. Tonight, we're exploring the observer's paradox, where the simple act of witnessing the past could collapse all of history into a single, irreversible outcome, where your eyes become weapons that kill possibility itself. Let me explain what quantum mechanics tells us about reality. At the smallest scales, particles don't have definite positions or velocities. They exist in what we call superposition, a ghostly state of being multiple things at once. An electron isn't just here or there. It's both here and there, and everywhere in between, all at the same time. It's only when we observe it, when we measure it, that it collapses into a single, definite state. This isn't philosophy. This is experimental fact. We've proven it thousands of times in laboratories around the world. The double-slit experiment shows that particles behave like waves, passing through multiple paths simultaneously until we observe which path they take. The moment we look, the wave function collapses. Multiple possibilities become single reality. Now apply this to time travel. You step into your machine and journey back 50 years. But here's what physics tells us. Until you arrived, until you observed it, the past existed in a state of quantum superposition, not just at the particle level, but potentially at the macroscopic level. Every event that wasn't directly observed, every moment that happened without witnesses, existed as a probability cloud of could-have-beens. Your arrival changes everything, not because you do anything, but because you see. Your observation collapses wave functions that have been in superposition for decades. Events that were quantum uncertain suddenly become classically definite. The past crystallizes around your presence like water freezing into ice. Consider a simple scenario. You travel back to 1974. You materialize in an empty field at night. No one sees you arrive. But you see the field. You see the stars. You see a distant farmhouse with one window lit. Until you arrived, quantum mechanics suggests that farmhouse existed in a superposition of states. The light could have been on or off. Someone could have been home or away. The uncertainty wasn't just in your knowledge. It was in reality itself. But now you've observed it. The light is definitely on. Someone is definitely home. The wave function has collapsed. History has been forced to choose. And that choice ripples outward through space-time. This gets worse when you realize what observation actually means in quantum mechanics. It's not about conscious awareness. It's about any interaction that carries information. Every photon that bounces off your retina is an observation. Every air molecule that touches your skin is an observation. Every gravitational interaction between your mass and the Earth is an observation. You're not just a witness to the past. You're a walking, breathing observation machine, collapsing wave functions wherever you go. The implications are staggering. History might not be the fixed, immutable thing we imagine. Instead, it might be a vast cloud of probabilities, temporarily frozen into definiteness only where and when it was observed. The unwitnessed moments of the past could still be quantum fluid, waiting for an observer to force them into being. Think about all the moments in history that had no witnesses. A tree falling in an empty forest in 1823. A rock rolling down an unseen mountainside in 1492. A fish dying in the deep ocean in the year 1000. Without observers, these events might exist only as probabilities. The tree both fell and didn't fall. The rock both rolled and didn't roll. The fish both died and didn't die. Until a time traveler arrives and looks. But here's where the paradox becomes truly mind-bending. Your observations in the past don't just collapse wave functions. They collapse them in ways that must be consistent with the future you came from. But the future you came from was built on a past that was already collapsed by other observations. You're trying to force a new observation onto a framework that's already been observed into existence. It's like trying to rebuild a house while living in it. Every board you move changes the structure you're standing on. Every observation you make in the past changes the quantum foundation of the future you came from. But you came from that future, so it must have existed. So the past must have been observed in a particular way. But now you're observing it differently. Scientists have proposed that this might be why we've never met time travelers. The observer's paradox doesn't just make time travel dangerous, it might make it impossible. The moment you try to observe a past that led to your existence, you create quantum inconsistencies that reality cannot resolve. The universe might simply prevent such observations from occurring, or worse, it might not prevent them. It might allow them and deal with the consequences through quantum decoherence. Your observations might split reality into multiple branches, each internally consistent but mutually exclusive. Every moment you spend in the past, you're creating new timelines, new universes, new realities. You're not traveling through time, you're shattering it into infinite fragments. There's an even more disturbing possibility. What if the past you travel to isn't the real past at all? What if the universe, in order to prevent paradoxes, creates a kind of quantum simulation of the past for you to observe? You think you're in 1974, but you're really in a bubble of space-time that looks like 1974, acts like 1974, but isn't connected to the real timeline. You're observing a phantom, a quantum echo that dissolves the moment you leave. This would explain why we've never seen evidence of time travelers. They might be traveling all the time, but they're not traveling to our past. They're traveling to quantum shadows of the past, observer-created pocket universes that exist only for them. But the deepest part of the paradox is this. If observation collapses quantum states, and if the past was in superposition until observed, then who collapsed the original timeline? Who was the first observer? Every effect needs a cause, but in a universe with time travel, cause and effect become circular. The past creates the future, which travels back to observe the past, which creates the future. We're left with a chicken and egg problem on a cosmic scale. The universe needs observers to collapse it into definiteness, but observers need a definite universe to evolve in. Time travel threatens to unravel this delicate balance, to expose the quantum scaffolding that holds reality together. Consider what happened in quantum physics experiments when scientists tried to observe which slit a particle went through in the double slit experiment. The mere presence of a detector, even when it wasn't recording, changed the outcome. The possibility of observation was enough to collapse the wave function. Now imagine you're that detector, but for all of history. Your mere presence in the past, your potential to observe, might be enough to crystallize events that should have remained uncertain. This brings us to the most unsettling implication of all. What if we're living in a collapsed timeline right now? What if our present is the result of future observers who have already traveled back and crystallized our past through their observations? Every historical event we take for granted might be the result of temporal observation, frozen into definiteness by the eyes of travelers from tomorrow. The observer's paradox suggests that time travel isn't just about moving through time. It's about the fundamental nature of reality itself. It forces us to question whether the past really exists in any meaningful way, or whether it's just a probability cloud waiting for observation. It makes us wonder whether history is discovered or created, whether archaeology is about finding facts or collapsing possibilities. When you look at old photographs, you're not just seeing the past. According to quantum mechanics, you might be creating it. Your observation, even decades later, might be reaching back through time to collapse wave functions, to force reality to choose what actually happened. Every historical document we read, every artifact we uncover, every fossil we discover, might be both revealing and creating history simultaneously. The next time you think about the past, remember this. Until someone observes it, it might not exist in any definite form. It might be a vast quantum foam of possibilities, waiting for an observer to give it shape. And if someone from our future ever travels back to our present, their observations might rewrite everything we think we know. We assume the past is fixed because we remember it. But memory itself might be part of the observation that fixes it. We're not just remembering the past, we're observing it into existence, moment by moment, memory by memory, thought by thought. And somewhere, somewhen, a time traveler might be watching us right now, their observation collapsing our present into their past, forcing us to be exactly who we are, exactly where we are, with no other possibility allowed. We think we have free will, but we might just be quantum possibilities that have already been observed into inevitability by eyes that won't exist for another 1,000 years. The observer's paradox reveals the ultimate truth about time travel. It's not about changing the past, it's about creating it. Every observer is a god of their own timeline, collapsing infinite possibilities into single realities with nothing more than a glance. And once collapsed, once observed, those possibilities can never be recovered. The other paths, the other choices, the other histories are lost forever in the quantum foam. Predestination paradox. You're about to hear a story that will make you question whether free will exists at all. In 1941, a science fiction writer named Robert Heinlein wrote a short story about a man who travels back in time and becomes his own father. The character exists because he traveled back in time, but he could only travel back in time because he existed. No beginning, no end, just an infinite loop of causality eating its own tail. Tonight, we're diving into the predestination paradox, the most elegant and terrifying of all temporal paradoxes. It's the one that doesn't break reality. Instead, it reveals that reality might be far stranger than we ever imagined. A prison where the walls are made of time itself, and where every attempt to escape only builds them higher. Let me start with something simple: a watch. Imagine you're sitting in your study in 2025 when your future self appears. They hand you an antique pocket watch and tell you to keep it safe. They disappear. You hold on to that watch for 20 years. In 2045, you travel back to 2025 and give the watch to your younger self. The same watch, the exact same moment. The loop is complete, but here's the question that should keep you awake at night. Where did the watch come from? Who made it? When was it created? The watch exists because you gave it to yourself, but you only have it because you gave it to yourself. It has no origin, no manufacturer, no point of creation. It simply exists, trapped in a causal loop, forever circling through the same 20 years of time. This is the predestination paradox in its purest form. Events that cause themselves, objects with no origin, information that comes from nowhere. It's a paradox that doesn't destroy logic, it completes it. It creates a closed circle where beginning and end meet and become meaningless concepts. But it gets worse, so much worse. Consider the assassination of Archduke Franz Ferdinand in 1914, the event that triggered World War I. Millions died because of that single bullet. The world changed forever. Now imagine a history student from 2150 becomes obsessed with preventing this tragedy. They travel back to stop the assassination. They arrive in Sarajevo on June 28, 1914. They see Gavrilo Princip raising his gun. They rush forward to stop him. In the struggle, the gun goes off. The bullet, deflected from its original path, still hits the Archduke, still kills him. The student realizes with horror that they didn't prevent the assassination. They caused it. They always caused it. History recorded that Princip fired the fatal shot, but it was only fatal because a time traveler tried to stop it. The student returns to their own time, traumatized, and writes about their experience in a journal. Years later, another student reads that journal, becomes obsessed with preventing the assassination, and travels back in time to stop it. The same student, reading their own journal, the loop closes. They were always destined to travel back, always destined to fail, always destined to cause the very thing they tried to prevent. This is where the paradox reveals its true horror. It's not just about objects or events, it's about destiny itself. In a universe with predestination paradoxes, free will becomes an illusion. Every choice you think you're making freely might actually be predetermined by effects from your own future. Think about Shakespeare for a moment, one of history's greatest writers. But what if Shakespeare never wrote any of his plays? What if a time traveler, devastated to discover that Shakespeare never existed or was just an ordinary man, traveled back with complete copies of all the plays? They give them to a struggling actor named William Shakespeare, who publishes them under his name. The plays become famous. History records Shakespeare as a genius. Centuries later, someone reads those plays, travels back in time with them, and gives them to Shakespeare. Who wrote the plays? The time traveler didn't write them. They just copied them from history. Shakespeare didn't write them. He just copied them from the time traveler. The plays wrote themselves. They are information with no author, creativity with no creator, art that emerged from the void fully formed. The implications make physicists nauseous. Information, according to thermodynamics, should degrade over time. Entropy should increase. But in a predestination paradox, information circulates forever without degradation. The watch never ages beyond a certain point. The plays never change. The loop preserves them perfectly, violating the second law of thermodynamics, unless the universe has a defense mechanism. Some scientists propose that each loop might introduce tiny changes. Quantum fluctuations, molecular wear, copying errors. Over infinite loops, these changes would accumulate until the paradox dissolves. The watch crumbles to dust. The plays become gibberish. The assassination fails to happen. Reality heals itself through entropy. But others argue the opposite. They say predestination paradoxes are evidence that time isn't linear at all. Past, present, and future exist simultaneously in what physicists call the block universe. We experience time sequentially, but from a higher dimensional perspective, all moments exist at once. The watch doesn't travel through time. It exists across time, a four-dimensional object that happens to loop back on itself. In this view, the paradox isn't a problem to be solved. It's a glimpse of the true nature of reality. Every moment of your life, every decision you'll ever make, already exists somewhere in the block universe. You're not creating your future, you're discovering it. And if time travel is possible, some of those discoveries might loop back and cause themselves. Here's a thought experiment that will haunt you. You're 30 years old, struggling with a crucial life decision. Should you take that job, marry that person, move to that city? Suddenly, your 60-year-old self appears. They tell you exactly what to choose. They know because they lived it. You follow their advice, and your life unfolds exactly as they described. 30 years later, you travel back and give your younger self the same advice. Did you ever really make a choice? Or were you always destined to receive that advice, follow it, and eventually give it? The loop has no beginning where you made a free decision. It's turtles all the way down, each decision caused by its own effect, each choice predetermined by its own outcome. The predestination paradox appears everywhere in our fiction because it speaks to our deepest fears about fate and freedom. Harry Potter survives Voldemort because Voldemort marked him as his equal, but Voldemort only marked him because of a prophecy about someone who would defeat him. But the prophecy only came true because Voldemort tried to prevent it. John Connor sends Kyle Reese back in time to protect his mother, but Kyle Reese becomes John Connor's father, meaning John Connor orchestrated his own conception. But what if fiction is trying to tell us something about reality? What if we're all caught in predestination paradoxes we can't see? Every coincidence that changed your life, every chance meeting that led to something important, every narrow escape from disaster, what if these weren't random? What if they were effects reaching back from your future to cause themselves? Consider DNA. The genetic code that makes you who you are. It came from your parents, who got it from their parents, stretching back through evolution to the first replicating molecules. But what if those first molecules were created by time travelers? Future humans who traveled back to seed Earth with life, knowing it would evolve into them. Life would be its own cause, evolution its own effect, existence itself a grand predestination paradox. Some physicists believe predestination paradoxes might be the universe's way of preventing other paradoxes. The grandfather paradox, where you kill your own grandfather, is impossible because the universe arranges events to prevent it. You try to kill your grandfather, but the gun jams. You try again, but you miss. You try poison, but he doesn't drink it. Every attempt fails because your existence proves that every attempt always failed. The universe protects itself through predestination. This self-consistency principle suggests that time travel is only possible if it doesn't change anything. You can travel to the past, but only to do what you always did. Your time travel was always part of history. The strangers in old photographs who look out of place, time travelers who were always there, the mysterious benefactors who funded crucial inventions, time travelers who always funded them. Every anomaly in history might be a predestination paradox we haven't recognized yet. But here's the truly terrifying thought. If predestination paradoxes are real, then somewhere, somewhen, they're happening. The universe might be full of causal loops, objects with no origin, information from nowhere, and we'd never know. They would look completely normal to us because they were always part of our history. The book on your shelf might have no author. The idea in your head might have no source. The decision you're about to make might not be yours at all. The predestination paradox suggests that the universe isn't just stranger than we imagine. It's stranger than we can imagine. Cause and effect, the fundamental assumption underlying all of science, might be more flexible than we thought. Events might not need causes. Objects might not need origins. Information might not need sources. The universe might be full of things that exist simply because they exist. Tautological realities that define themselves. And you, listening to these words right now, might be part of a predestination paradox yourself. Maybe you'll be inspired by this to study physics, to build a time machine, to travel back, and create the very circumstances that led to you hearing this. Maybe these words exist because you will someday make them exist. Maybe I'm speaking them because you will travel back to ensure I speak them. The loop might be closing right now as these thoughts enter your mind. Your future might be reaching back to touch your present, to guide you toward a destiny that was always yours, that was always waiting, that was always going to happen because it already has happened, will happen, is happening right now. When you wake up tomorrow, look carefully at the world around you. Look for the loops, the things that seem to cause themselves, the coincidences that are too perfect, the objects whose origins you can't quite remember, the decisions that feel both freely chosen and inevitable. You might be living inside a predestination paradox and not even know it. Or worse, you might know it and be powerless to change it, because in a predestination paradox, knowledge itself becomes part of the loop. You know because you always knew. You always knew because you will know. You will know because you know right now. The circle is complete. The paradox is perfect. And somewhere in time, a watch is passing from future to past to future again, forever, with no beginning and no end, just like the universe itself, just like your thoughts, just like these words, which might exist only because you will someday make them exist. Reverse causality paradox. There's a phone ringing in 1963. A scientist picks it up and hears a voice describing in perfect detail how to build a revolutionary new computer chip. The technology is decades ahead of its time. The scientist builds it, patents it, becomes rich and famous. The chip changes everything, accelerates the digital revolution by 30 years. In 2025, archaeologists discover the scientist's personal journal. In it, they find a confession. The voice on the phone was his own. He had traveled back from 1995 to give himself the information. But here's what breaks reality. He only knew how to build the chip because he had already built it, using instructions he would someday give himself. Tonight, we're exploring the reverse causality paradox, where the future doesn't just influence the past, it creates it. Where effects come before causes, where consequences precede actions, where the arrow of time doesn't just reverse, it ties itself into knots that make physicists question everything they thought they knew about reality. Let me explain what causality means to physics. It's the foundation of everything, the axiom that cannot be broken. Causes must come before effects. You push a glass, then it falls. You light a match, then fire appears. The sequence is sacred. It's what separates reality from madness. But time travel doesn't just threaten this sequence, it obliterates it. Consider what happens in your brain when you make a decision. Neurons fire, chemicals release, electrical signals propagate. These physical events cause your decision. But what if your decision already happened? What if 5 minutes from now, you've already chosen, and that future choice is reaching back to cause your neurons to fire right now? Your brain isn't making the decision, it's receiving it from your future self. This isn't science fiction. This is what physicist John Wheeler proposed with his delayed choice experiments. He showed that observing a particle now can determine what path it took in the past. The measurement doesn't just reveal the past, it creates it. The effect, your observation, causes the cause, the particle's path. Quantum mechanics already allows reverse causality. Time travel just makes it macroscopic. Here's an experiment that actually happened. Scientists in 2017 performed what they called a Maxwell's demon experiment. They showed that information from the future could be used to extract energy in the present, appearing to violate thermodynamics. The system worked because future measurements influence past states. Effects preceded causes. The arrow of time pointed backward, at least for information. Now scale this up to human existence. You're born in 1990. You grow up, live your life, make choices. In 2050, you discover time travel. You realize your entire life has been shaped by mysterious interventions, anonymous donations at crucial moments, perfect advice from strangers who disappeared, lucky breaks that seemed impossible. You investigate and discover the truth. Every intervention was you. You've been guiding your own life from the future. But think about what this means. Your childhood was shaped by an adult who only exists because that childhood happened. Your education was guided by knowledge you only have because of that education. Every formative experience that made you who you are was orchestrated by the person those experiences created. You didn't become yourself. You caused yourself. The paradox goes deeper when you consider knowledge. You know things because you learned them. But what if you learned them from yourself? A mathematician struggles with a proof for decades. Finally, as an old woman, she solves it. She travels back and anonymously sends the solution to her younger self. The younger self publishes it, becomes famous, spends her life understanding it. She only understands it because she received it. She only could send it because she understood it. Where did the proof come from? Not from the older self, she just remembered it. Not from the younger self, she just received it. The knowledge exists without origin, a pure idea that bootstrapped itself into existence through reverse causality. The future created the past, which created the future. This breaks our understanding of information theory. Information should have a source. It should be created by computation, by thought, by physical processes. But in reverse causality, information can be its own source. The answer exists because it exists. The knowledge is known because it is known. Scientists have discovered that this might already be happening at the quantum level. Retrocausality, they call it. Quantum states that are influenced by future measurements. Particles that know their destiny and adjust their present accordingly. The future reaching back to ensure its own existence. Every quantum event might be a negotiation between past and future, a handshake across time that determines what reality becomes. But here's where it gets truly unsettling. If reverse causality is real, then prophecy is possible. Not mystical prophecy, but scientific prophecy. Information from the future influencing the past. That feeling you get that something bad is about to happen. Maybe your future self is warning you. That sudden inspiration that solves a problem. Maybe you're receiving the solution from tomorrow. Consider the stock market. Every trader dreams of knowing tomorrow's prices today. But if someone could send that information back, even just 24 hours, they would become rich. But their trades would change the market, changing the prices, changing the information they send back. The market would become a chaotic feedback loop of reverse causality, effects causing their own causes in an endless spiral. Some economists believe this might already be happening. They call them market anomalies, patterns that shouldn't exist, predictions that are too accurate, crashes that happen for no reason except that they were always going to happen. The market predicting itself, causing itself, trapped in loops of reverse causality that no one fully understands. The human brain might be particularly susceptible to reverse causality. Consciousness remains a mystery to science. We don't know how neurons create experience, how chemistry creates qualia, how matter creates mind. But what if consciousness isn't created by the brain? What if it's received by the brain? What if your thoughts right now are being influenced by your thoughts tomorrow? This would explain precognition, intuition, déjà vu. Your brain isn't malfunctioning. It's receiving signals from its own future. That decision you're struggling with. Maybe you've already made it, and your current uncertainty is just the process of receiving that future decision. Free will becomes even more complicated when your choices might be echoes of choices you haven't made yet. Here's an experiment you can try. Think of a number between 1 and 10. Got it? Now consider this. What if you chose that number because tomorrow you'll think back to this moment and remember choosing it? The memory causes the choice. The effect causes the cause. The number exists in a causal loop, chosen because it was chosen, remembered because it will be remembered. The reverse causality paradox appears in nature in ways we're just beginning to understand. Quantum biology suggests that photosynthesis might use retrocausality, with future states influencing past states to maximize efficiency. Birds might navigate using quantum entanglement that involves retrocausal effects. Evolution itself might be guided by reverse causality, with future survival influencing past mutations. Think about that. Evolution shaped by its own future. Species developing traits they'll need for challenges that haven't happened yet. The dinosaurs dying out because mammals were always going to inherit the Earth. Humans developing intelligence because we were always going to need it. The future pulling the past toward itself like gravity pulls matter. This changes everything about destiny. It's not that the future is predetermined, it's that the future is self-determining. It reaches back and creates the conditions necessary for its own existence. Every successful person who says they knew they would make it, maybe they did know. Maybe their success reached back and told them. Every failure that seemed inevitable, maybe it was, because it made itself inevitable through reverse causality. The paradox becomes personal when you realize you might be living it right now. That important person you met by chance. Maybe you arranged it from your future. That mistake that taught you a crucial lesson. Maybe you ensured you would make it. Your entire life, might be a carefully orchestrated sequence of reverse causality, with your future self as the conductor. But who's really in control? Your present self making choices that create your future, or your future self reaching back to create your present? The answer might be both and neither. You might exist in a stable time loop where present and future create each other simultaneously, every moment both causing and caused by every other moment. Scientists studying reverse causality have noticed something disturbing. The universe seems to resist certain changes while allowing others. Try to create a paradox, and quantum effects prevent it. Try to send information back that would prevent its own sending, and noise corrupts it. It's as if the universe has an immune system against temporal paradoxes, but that immune system itself works through reverse causality. The implications are staggering. Justice becomes complicated when effects precede causes. How do you punish someone for a crime they haven't committed yet, but definitely will commit? How do you reward someone for an achievement that only happened because you rewarded them for it? Law, ethics, responsibility all break down when causality runs backward. Even consciousness might be a reverse causality phenomenon. Your experience of now might be created by your memory of it tomorrow. You're not experiencing the present. You're remembering the future's memory of the present. Every moment of awareness is an echo from tomorrow, a signal from your future self that creates your present self. The reverse causality paradox suggests that time isn't a river flowing from past to future. It's more like a negotiation, with past and future haggling over what the present should be. Every moment is a compromise between what was and what will be, with causality flowing both ways simultaneously. And somewhere, a phone is ringing in 1963. A voice is describing impossible technology. A scientist is taking notes, not knowing the voice is his own, not knowing he's creating the future that will create him. The loop is closing. The paradox is complete. And we're all trapped inside it, causing our own causes, affecting our own effects, forever and always. Tomorrow, when you remember reading this, that memory might be reaching back to create this moment right now. Your future understanding might be causing your present reading. These words might exist not because I wrote them, but because you will remember them. And your memory of them might be what causes me to write them in the first place. The arrow of time isn't broken. It's pointing in all directions at once. Past creates future, creates past creates future. An endless cycle of causality where beginning and end have no meaning. Where every moment is both cause and effect, both chicken and egg, both question and answer. Parallel universe paradox. You're looking at yourself through a window, not a reflection, not a video. Another you, living another life, making different choices. They look back, equally shocked. Between you lies not glass, but the thinnest possible membrane between parallel universes. You both reach out to touch the barrier, and the moment your fingers meet, both realities begin to shatter like mirrors, reflecting mirrors into infinity. Tonight, we're exploring the parallel universe paradox, where time travel doesn't just change the past, it reveals that there might be infinite pasts, infinite presents, infinite futures, all existing simultaneously, all equally real, and all threatened by the simple act of moving between them. In 1957, Hugh Everett III proposed something that made physicists physically uncomfortable. He said that every quantum event creates a split in reality. Every particle that could go left or right goes both ways, creating two universes. One where it went left, one where it went right. Both equally real. Both containing conscious observers who think their universe is the only one. The math was sound. Too sound. It solved problems in quantum mechanics that had plagued physicists for decades. But the implications were so disturbing that his advisor, John Wheeler, tried to talk him out of publishing it. Everett's idea meant that reality branches billions of times per second. Every possible outcome of every possible event creates a new universe. Right now, as particles in your brain fire, you're splitting into countless versions of yourself, each thinking slightly different thoughts. But here's where time travel turns this into a paradox. If you travel back in time, which universe do you arrive in? The past of your specific timeline, or one of the infinite other pasts that are almost but not quite identical? And if you change something, do you create a new branch, or do you shift into an already existing parallel universe where that change always happened? Consider this scenario. You travel back 10 years to prevent a car accident that killed your best friend. You succeed. Your friend lives. You return to the present expecting to find them alive. But which present do you return to? There are infinite versions where your friend lived. In some, they became a doctor. In others, a criminal. In some, they married your sister. In others, they married you. Which universe is the right one? Which present do you deserve? The paradox deepens when you realize that in a multiverse, every possible version of history already exists. There's a universe where Hitler won World War II. There's a universe where Rome never fell. There's a universe where dinosaurs never went extinct and evolved into intelligent beings. These aren't hypotheticals. According to quantum mechanics, they're as real as the universe you're in right now. Time travel in a multiverse doesn't change history. It reveals that all histories already exist. You're not altering the past, you're navigating between pre-existing pasts. Every change you think you're making already exists somewhere in the infinite branches of reality. You're not a time traveler, you're a universe traveler, sliding between parallel worlds that look like different times. But here's what breaks mathematics. If there are infinite universes, then there are infinite versions of you. Some of them have time machines. Some of them are traveling to the same moment you are. The probability of meeting another version of yourself approaches certainty. The past becomes crowded with infinite time travelers, all trying to change the same events, all creating or discovering new branches, all equally real. Scientists call this the measure problem. In an infinite multiverse, everything that can happen does happen infinite times. Every possible outcome has infinite instances. How do you calculate probability when everything is equally infinite? How do you make choices when every choice is made infinite times by infinite versions of you? The paradox becomes personal when you realize what this means for identity. You think you're one person with one history, but in the multiverse, you're a cloud of possibilities, a statistical distribution across infinite universes. The you that exists in this moment is just one arbitrary sample from an infinite set. Your memories might not even be from this universe. They might be quantum leakage from parallel versions of you. Think about your childhood memories. That day at the beach when you were 7. In this universe, you built a sandcastle. But in another, you found a strange shell. In another, you nearly drowned. In another, you never went to the beach at all. Which memory is real? They all are. And sometimes late at night when your mind drifts, you might remember the shell you never found, the drowning that never happened, the beach you never visited. Quantum physicists have discovered that particles can interfere with their own parallel versions. An electron can interact with itself across parallel universes, creating interference patterns that we can measure. If particles can do this, why not people? Your thoughts right now might be interfering with the thoughts of parallel yous. Your decisions might be influenced by the decisions they're making in their universes. This could explain intuition. That gut feeling that something is wrong might be a parallel version of you experiencing danger. That sudden certainty about a decision might be millions of parallel yous all choosing the same thing. They're quantum states reinforcing each other across dimensional barriers. You're not psychic. You're multiversally entangled with yourself. The technology to detect parallel universes might be closer than we think. Scientists have proposed experiments using quantum computers that could prove the existence of parallel realities. They would send information into quantum superposition, where it exists in multiple states simultaneously, then check if it interacted with versions of itself we can't directly access. If it did, It would prove that parallel universes aren't just mathematical abstractions. They're real, physical places. But here's where the paradox becomes a nightmare. If you can detect parallel universes, you can communicate with them. If you can communicate with them, you can travel to them. And if you can travel to them, you encounter the ultimate temporal paradox, meeting yourself. Not your past self or future self, but your parallel self. Someone who is you but isn't you, who has your memories up to a certain point, then diverges, who made different choices, lived different experiences, became a different person. Are they you or someone else? Do you have the right to interfere in their life? Do they have the right to interfere in yours? Imagine discovering that in another universe, you're wildly successful. You're tempted to travel there, to replace that version of yourself, to steal their life. But that version of you might have the same idea about your life. Across infinite universes, infinite versions of you might all be trying to escape to better realities, creating a multiversal refugee crisis where everyone is you. The parallel universe paradox suggests that time travel might be impossible to control. You think you're traveling to 1985, but which 1985? There are infinite versions, each slightly different. The one where Reagan was never shot, the one where Chernobyl never happened, the one where your parents never met. Even with perfect technology, hitting the exact past of your exact universe would be like firing an arrow at a specific atom in a specific grain of sand on a specific beach, on a specific planet in a specific galaxy. The odds are literally infinitesimal. This might be why we've never met time travelers. They exist, but they're lost in the infinite maze of parallel universes. Every attempt to return home takes them to another almost identical timeline. They're quantum orphans, doomed to wander through infinite variations of history, never quite finding their way back to their original reality. Some physicists believe consciousness might be the key. They propose that consciousness isn't generated by the brain, but exists across parallel universes simultaneously. Your sense of self, your continuity of experience, might be a quantum phenomenon that spans multiple realities. You're not one person. You're a multiversal entity experiencing one specific timeline while unconsciously aware of all the others. This would explain why quantum mechanics seems to require conscious observation. It's not that consciousness creates reality. It's that consciousness exists across all realities simultaneously, and the act of observation is just choosing which reality to experience. Every measurement, every decision, every thought is a navigation through the multiverse. The deeper horror is that if parallel universes exist, then somewhere, everything horrible you can imagine is happening. There's a universe where humanity went extinct yesterday. There's a universe where you died this morning. There's a universe where everyone you love is suffering. These aren't possibilities. In a multiverse, they're certainties. They're happening right now, just a quantum membrane away. But equally, everything beautiful you can imagine is also happening. There's a universe where humanity has achieved perfect peace. There's a universe where you're living your absolute best life. There's a universe where every problem has been solved, every disease cured, every conflict resolved. Paradise exists. It's just in another parallel universe. The parallel universe. Paradox forces us to confront the ultimate question. If all possibilities exist, do our choices matter? If every decision creates a universe where you chose differently, is there any meaning to choosing at all? You're not changing reality. You're just selecting which reality to experience. Free will becomes not about creating outcomes, but about navigating between pre-existing outcomes. Right now, as you listen to these words, infinite versions of you are listening to slightly different versions. In some universes, I chose different words. In some, you stopped listening paragraphs ago. In some, time travel has already been invented, and this is historical documentation. In some, these words are the key that unlocks the secret of parallel universes. And in at least one universe, you're not listening at all. You're speaking these words. You're me, and I'm you. And we've somehow switched places through a quantum glitch that neither of us understands. You're trying to warn yourself about something. but the message is getting scrambled across dimensional barriers. The parallel universe. Paradox isn't just about time travel or quantum mechanics. It's about the nature of existence itself. Are we single beings living single lives? Or are we infinite beings experiencing infinite lives simultaneously, under the illusion that only one is real? When you dream of different lives, are those dreams or glimpses into parallel realities? When you imagine how things could have been different, are you imagining or remembering? Tomorrow, when you wake up, you might not be in the same universe you fell asleep in. The differences might be too small to notice. A slightly different shade of blue in the sky, a bird singing a slightly different song, a memory that feels just a little bit wrong. You'd never know. You'd assume continuity because that's what consciousness does. It creates the illusion of a single continuous experience from what might be a chaotic journey through infinite realities, the parallel universe. Paradox reveals the ultimate truth. We might all be time travelers, jumping between parallel universes with every quantum event, every decision, every thought. Reality isn't solid. It's a foam of infinite possibilities, and we're bubbles floating through it, sometimes merging, sometimes splitting, always wondering if we're in the same universe we started in. The causal loop paradox. A detective stands over a crime scene, studying the evidence. A broken window, muddy footprints, a note written in handwriting she doesn't recognize, but somehow knows she's seen before. The message is simple. Check the basement at midnight. She follows the lead and prevents a disaster, saving dozens of lives. Years later, she discovers time travel exists. On impulse, she journeys back to warn herself about that disaster. She breaks a window to get into the building, leaves muddy footprints, writes a note in her own disguised handwriting. Check the basement at midnight. The crime scene she investigated was the one she created. The clue she followed was the one she left. But if she only knew to leave the warning because she received it, where did the information originally come from? The loop has no beginning, no first cause, just an endless circle of causation chasing its own tail through time. The causal loop paradox is perhaps the purest expression of time travel's assault on our understanding of cause and effect. It's not about preventing your own existence like the grandfather paradox, or creating information from nothing like the bootstrap paradox, or fulfilling prophecies like predestination. It's about causation itself becoming circular, like a river that flows into itself, a story that tells itself, a thought that thinks itself into being. Imagine you're walking through a forest and come across a perfect circle of mushrooms, what folklore calls a fairy ring. Each mushroom releases spores that help the next mushroom grow, which releases spores for the next, and so on around the circle. But mushrooms die and regenerate, so you can trace the causation back. This mushroom caused that one, which caused the next. With a causal loop in time, there's no such degradation, no generation to point to as the first. The circle exists outside our normal understanding of sequences and origins. I remember reading about a physicist who became obsessed with this paradox. She spent years trying to map out the mathematics of causal loops, filling chalkboards with equations that curved back on themselves. One day, a student asked her, "But where does the loop start?" She laughed and said, "You're asking the wrong question. It's like asking where a circle begins. The loop doesn't start anywhere because it doesn't exist in linear time. It exists as a complete structure, a pattern in space-time that simply is." This connects to one of the deepest questions in philosophy. Why is there something rather than nothing? We usually think everything needs a cause, a reason for existing. But what caused existence itself? Some philosophers suggest that existence might be its own cause, a causal loop at the foundation of reality. The universe exists because it exists, causing itself through a kind of cosmic bootstrap that our linear thinking can barely grasp. Consider how we normally understand causation. A stone drops into a pond, causing ripples. The ripples spread outward, causing lily pads to bob, causing a frog to jump, causing a heron to take flight. It's a chain of causes and effects, each link connected to the next, stretching from past to future. But what if the heron's flight somehow caused the stone to drop? Not metaphorically, but literally, through a loop in time. The chain becomes a circle, and suddenly our questions about first causes become meaningless. The fascinating thing about causal loops is that they don't necessarily violate any laws of physics. The equations of general relativity, Einstein's theory of gravity and space-time, actually permit what physicists call closed time-like curves. These are paths through space-time that loop back to their own beginning. An object following such a path would meet its younger self, creating the possibility of causal loops. The physicist Kurt Gödel, famous for his incompleteness theorems in mathematics, found a solution to Einstein's equations that described a rotating universe where causal loops were possible everywhere. But here's where things get truly strange. In a causal loop, information or events exist without origin, yet they're perfectly self-consistent. The loop creates itself, maintains itself, explains itself. It's like a perfect circle drawn without beginning or end, existing complete and whole. Every event in the loop causes and is caused by every other event. The future creates the past, which creates the future, not in sequence, but simultaneously, eternally. Think about your own consciousness for a moment. You're aware of being aware. You think about thinking. This creates a kind of causal loop in your mind. Your thoughts observe themselves, creating the self that observes the thoughts. Consciousness might be the one causal loop we all experience directly. The strange loop of self-awareness that philosophers and neuroscientists struggle to explain. The mind causes itself to exist through the very act of contemplating its existence. Douglas Hofstadter, in his explorations of consciousness and self-reference, suggests that causal loops might be essential to complex systems. When a system becomes sophisticated enough to model itself, to contain a representation of its own processes, it creates these strange loops of causation. The map includes itself, the story contains its own telling, the equation calculates itself. Perhaps causal loops aren't paradoxes to be avoided, but fundamental features of any sufficiently complex reality. There's a beautiful example from computer science that illustrates this. A compiler is a program that translates human-readable code into machine language. But here's the mystery. The compiler itself is a program that needs to be compiled. How do you compile the first compiler? This is called the compiler bootstrap problem. The solution involves a causal loop through time. You write a simple compiler in machine language, use it to compile a better compiler, then use that to compile an even better one, eventually creating a compiler so sophisticated it could have compiled itself from the beginning. The loop closes when the compiler becomes capable of creating itself. This happens in evolution too. DNA contains the instructions for building proteins, but you need proteins to read and replicate DNA. Which came first? Scientists suspect that early life involved RNA, which can both store information and catalyze reactions, creating a causal loop where RNA helps create more RNA. Life itself might have bootstrapped into existence through such loops, effects becoming causes, becoming effects, until the system stabilized into self-sustaining existence. The causal loop paradox becomes even more intriguing when we consider quantum mechanics. In the quantum world, particles can be entangled, their properties correlated in ways that seem to transcend normal causation. Measure one particle, and its entangled partner instantly assumes a corresponding state, regardless of the distance between them. It's not that one causes the other to change, rather, they're part of a single quantum state that exists as a unified whole. Some physicists suggest that causal loops might work similarly, existing as complete structures in space-time rather than sequences of causes and effects. John Wheeler, the physicist who coined the term black hole, proposed something even more radical. He suggested that the entire universe might be a single electron, traveling back and forth through time, weaving every electron and positron that has ever existed. In this view, all electrons are identical because they're the same electron, creating itself through an impossibly complex causal loop that generates all of reality. It's a wild idea, probably wrong, but it illustrates how causal loops might operate on cosmic scales. Consider a more mundane example. You're learning to ride a bicycle. To balance, you need to be moving, but to start moving confidently, you need to be able to balance. It seems like a causal loop. Balance causes movement, causes balance. Of course, in reality, you wobble and fall and gradually improve. But once you've learned, the skill maintains itself through this circular causation. Your body's adjustments cause stability, which allows the adjustments which maintain stability. The loop sustains itself. This happens in economics too. People spend money because they expect the economy to grow. The economy grows because people spend money. Confidence creates the conditions that justify confidence. Fear creates the conditions that justify fear. Markets are full of these causal loops, self-fulfilling prophecies that create the reality they predict. The stock market rises because investors believe it will rise, and their belief, translated into buying pressure, causes the rise they anticipated. Language itself involves causal loops. Words get their meaning from other words, definitions circling back on themselves. Look up any word in the dictionary, then look up the words in its definition, and keep going. Eventually, you'll return to where you started. Meaning exists not in any single word, but in the entire network of relationships, a vast causal loop where every word helps define every other word. But the causal loop paradox in time travel presents something more fundamental. It suggests that causation itself might be more flexible than we imagine. We think of cause and effect as an arrow pointing from past to future. But what if causation is more like a web, with influences running in all directions, including backward through time? What if the future doesn't just emerge from the past, but actively participates in creating it? There's a thought experiment I find particularly compelling. Imagine you receive a message from your future self with instructions for building a time machine. You follow the instructions, build the machine, and eventually send the same message back to your younger self. The information for building the time machine exists in a causal loop. But here's the key. The loop only exists if it's consistent. If the message contained errors, the machine wouldn't work, you couldn't send the message, and the loop would collapse. Only stable, self-consistent loops can exist. This might resolve the paradox. Perhaps the universe only permits causal loops that don't create contradictions. The loops that can exist are those that must exist. Perfect circles of causation that maintain their own consistency. It's like a mathematical equation that's only satisfied by certain values. The universe solves for self-consistency, and causal loops are part of the solution. Imagine time as a vast jigsaw puzzle. Most pieces connect in obvious ways, edge to edge, past to future. But some pieces have strange shapes that loop back, connecting to themselves through higher dimensions we can't directly perceive. These are the causal loops, necessary for the puzzle's completion, but defying our expectation that puzzles should be assembled linearly, one piece after another. The human brain might actually create small causal loops in its normal operation. When you anticipate something about to happen, your brain generates a prediction. This prediction influences your perception, making you more likely to notice evidence that confirms it. Your expectation partially creates the reality you expect. Athletes visualize success, and the visualization improves their performance, validating the visualization. The loop closes through the interaction of mind and body, future intentions creating present actions, creating future outcomes. Dreams offer another window into causal loops. In dreams, you might know something is about to happen because it already happened, or remember things that haven't occurred yet. Dream logic ignores linear causation, allowing effects to precede causes, endings to create beginnings. Perhaps dreams show us how consciousness might operate outside the normal flow of time, creating and navigating causal loops that seem paradoxical only from our waking perspective. Even in ordinary life, we experience hints of causal loops. You become friends with someone because you spend time together, and you spend time together because you're friends. You're confident because you succeed, and you succeed because you're confident. You love someone because they love you, and they love you because you love them. These aren't perfect causal loops. They develop over time, but they show how circular causation can create and maintain stable patterns in our lives. The causal loop paradox might be telling us something profound about the nature of existence. Perhaps reality isn't built from a foundation of first causes, but is more like a vast network of mutual causation, everything causing everything else in an intricate dance of interdependence. The Buddhist concept of pratyasamutpada, often translated as dependent origination, suggests something similar. Nothing exists independently. Everything arises through its relationships with everything else. As you lie there in the darkness, feeling your breath rise and fall, consider this. Each breath causes the next, and is caused by the previous one. But where did your first breath come from? It was caused by your birth, which was caused by your parents, reaching back through generations. But your breathing also reaches forward, each breath enabling the next moment of consciousness, the next thought, the next breath. You exist in a causal loop that extends through time, past and future, mutually creating each other through the present moment of your existence. The detective stands at the crime scene she will create years in the future. The broken window, the muddy footprints, the note in her own handwriting that she doesn't yet recognize. She investigates the clues she will leave, follows the trail she will make, prevents the disaster she already prevented. The loop completes itself, perfect and impossible, a circle in time that exists because it exists, explains itself through itself, a mystery that is its own solution. Perhaps that's the deepest truth the causal loop paradox reveals. Existence doesn't need an external cause or a first moment. It can bootstrap itself into being through networks of circular causation that our linear thinking struggles to grasp. The universe causes itself. Consciousness creates itself. Time loops back to ensure its own consistency. We search for beginnings and endings, for first causes and final effects. But reality might be more like an eternal dance where every step causes and is caused by every other step, where the dance dances itself into existence. The causal loop paradox doesn't just challenge our understanding of time travel, it challenges our understanding of existence itself. It suggests that the question, what caused it, might sometimes have no answer, not because we lack knowledge, but because the question assumes a linear chain of causation that doesn't always apply. Some things might simply be existing in perfect self-causing loops that need no external explanation or origin. In the silence between thoughts, in the space between cause and effect, perhaps you can sense them. The loops that hold reality together, the circles of causation that create and maintain the patterns of existence. Your next thought will cause the one after that, which will influence the next, which will loop back to affect how you remember this moment, which shapes who you are, which determines your next thought. The circle continues, always beginning, always ending, always complete. Polchinski's paradox, billiard ball paradox. A billiard ball rolls across a table toward a pocket that happens to be the mouth of a time machine. The trajectory is perfect, the speed precise. In exactly 47 seconds, the ball will enter the pocket and emerge from another pocket 30 seconds in the past. But here's where physics becomes poetry and simplicity becomes paradox. The ball emerges from that past pocket on a collision course with its younger self. The older ball strikes the younger ball, deflecting it away from the time machine pocket. But if the younger ball never enters the time machine, how can the older ball exist to deflect it? This is Polchinski's paradox, named after the physicist Joseph Polchinski, who proposed it in the 1990s as perhaps the cleanest, most mathematical expression of time travel's fundamental contradiction. Unlike other temporal paradoxes that involve human choices, murdered grandfathers, or mysterious melodies, this one strips everything down to pure physics. Momentum, angles, trajectories. No free will to complicate things. No consciousness to muddy the waters. Just Newton's laws playing out on a felt table with pockets that pierce through time itself. I find something beautifully honest about this paradox. It removes all the human drama and asks the universe a simple question. Can you contradict yourself? Can effect prevent cause? Can the future reach back and erase its own origin? The billiard ball doesn't choose its path, doesn't agonize over paradoxes. It simply follows the laws of physics, and those laws seem to tie themselves in an impossible knot. Polchinski developed this thought experiment while working on quantum gravity and string theory. He wanted to understand whether the laws of physics themselves would prevent time travel, or whether they could accommodate these strange loops of causation. The billiard ball became his perfect test subject, an object simple enough to analyze mathematically but complex enough to generate genuine paradoxes. Picture the scene more carefully. The table is perfectly smooth, no friction to complicate calculations. The ball is perfectly spherical, its surface uniform. We know its exact mass, position, and velocity. We can calculate precisely when it will reach the pocket, at what angle it will enter, how it will emerge in the past. This isn't fuzzy philosophy, but hard mathematics. And the mathematics seems to say, this is impossible. But here's where things get interesting. When physicists actually worked through the equations, they discovered something unexpected. While the paradoxical trajectory exists, where the ball prevents itself from entering the time machine, there are also self-consistent trajectories. The older ball could emerge at a slightly different angle, giving its younger self a glancing blow that changes its path but doesn't prevent it from entering the time machine. The blow ensures the older ball emerges at exactly the right angle to deliver that same glancing blow. The loop closes consistently. In fact, physicists found not just one self-consistent solution, but infinite solutions. The ball could graze its younger self lightly or hit it harder. It could strike from the left or the right. Each consistent solution creates a perfect loop where the older ball's intervention ensures its own existence. It's as if the universe offers infinite ways to avoid paradox, while still allowing the strange loops of time travel. This connects to something profound in physics called the principle of least action. Nature, it seems, is lazy in the most elegant way possible. Light takes the fastest path between points. Objects fall along trajectories that minimize action, a quantity related to energy and time. The universe solves complex equations automatically, finding paths that satisfy all constraints. Perhaps temporal consistency is just another constraint, and the universe naturally finds trajectories that avoid paradox. Think about water flowing down a hillside. It doesn't calculate the optimal path, doesn't solve differential equations. It simply flows, and in flowing, finds the path of least resistance. Every droplet influences every other droplet, creating rivulets, streams, rivers. The water solves the problem of descent through the simple act of descending. Perhaps time-traveling billiard balls would behave similarly, naturally finding self-consistent paths through space-time. But Polchinski's paradox raises a deeper question. Who or what chooses among the infinite self-consistent solutions? If a ball can emerge at various angles, all creating valid loops, what determines which actually occurs? This is where quantum mechanics enters the picture with its fundamental randomness. Perhaps all consistent histories occur in parallel quantum branches, or perhaps quantum uncertainty selects randomly among the valid options. Igor Novikov and his colleagues proposed what they called the principle of self-consistency. The only trajectories that can occur are those that don't create paradoxes. It's not that the universe actively prevents paradoxes, but that paradoxical situations simply cannot exist, like logical contradictions. You can write the words square circle, but you cannot draw one. Similarly, you can describe a paradoxical trajectory, but it cannot physically occur. This principle has a beautiful mathematical expression. In classical mechanics, we can usually specify initial conditions, position and velocity, and calculate exactly what happens next. But with closed time-like curves, time travel loops, we must solve what mathematicians call a boundary value problem. We need trajectories that match up consistently when they loop back on themselves. Only certain solutions satisfy these constraints, naturally eliminating paradoxes. Consider an analogy from music. When you tune a guitar string, you're finding frequencies where the wave reinforces itself, where the vibration traveling down the string arrives back at the starting point in phase with itself. These are the resonant frequencies, the notes that ring clear and true. Other frequencies create destructive interference, cancelling themselves out. Perhaps self-consistent time travel trajectories are like resonant frequencies in space-time, patterns that reinforce rather than contradict themselves. The billiard ball paradox also illuminates something curious about information and entropy. The second law of thermodynamics says entropy always increases. Things naturally become more disordered over time. But a billiard ball emerging from the past seems to violate this. It appears from nowhere, adding information to the universe. Where does this information come from? How does the universe maintain its accounting? One possibility is that time travel requires a kind of information exchange. The ball entering the future pocket must exactly match the ball emerging from the past pocket. Same mass, same temperature, same quantum state. This creates a constraint that might naturally select the unique self-consistent trajectory. The universe maintains its books by ensuring perfect correspondence between what enters and what emerges from the time loop. There's something almost musical about this correspondence. Imagine a fugue where a melody chases itself through time, each voice entering at precisely the right moment to harmonize with itself. The mathematical beauty of self-consistent trajectories has this same quality. Patterns that create themselves through their own perfect timing. Scientists have actually conducted experiments that capture something of Polchinski's paradox, though without actual time travel. They use light pulses in carefully arranged fiber optic loops, where the output can influence the input. The light doesn't travel backward in time, but the experimental setup creates similar logical structures, and consistently, they find that the system naturally evolves towards self-consistent solutions, avoiding paradoxes through what seems like an inherent wisdom in the physics itself. This brings us to a fascinating possibility. What if the universe is fundamentally computational, constantly solving equations to maintain consistency? Every particle interaction, every quantum event, might be part of a vast calculation ensuring that causality remains intact, even when it loops back on itself. The billiard ball finds its consistent trajectory because that's the only solution to the universe's equations. But there's another interpretation that's even stranger. Some physicists suggest that the presence of closed time-like curves might change the nature of physical law itself. Near a time machine, the usual rules of cause and effect might blur into something more complex. The billiard ball wouldn't simply follow Newton's laws, but would be guided by a deeper principle that encompasses both normal causation and temporal loops. Think about how gravity warps space around a massive object. Light still travels in straight lines from its perspective, but those lines curve through warped space. Perhaps time machines create a similar warping in causality itself. Effects still follow causes from a local perspective, but the causal structure curves back on itself, creating loops that seem paradoxical only from our limited viewpoint. Kip Thorne, the physicist who helped develop the theory of traversable wormholes, studied Polchinski's paradox extensively. He and his students found that quantum effects might be crucial. At the quantum level, particles don't have definite trajectories, but exist in superpositions of many paths. A quantum billiard ball would simultaneously take all possible paths, and only the self-consistent ones would reinforce through quantum interference. This quantum resolution has an elegant feature. It automatically selects not just any self-consistent solution, but the most probable one. The trajectories that barely graze, that create the minimal disturbance, would be quantum mechanically favored over violent collisions. The universe, it seems, prefers gentle consistency over dramatic intervention. There's a profound philosophical implication here. If physical laws naturally prevent paradoxes, if consistency is built into the fabric of reality, then perhaps the universe is more robust than we imagined. Time travel might not threaten causality, but reveal its deeper structure. The grandfather paradox, the bootstrap paradox, Polchinski's paradox, these might not be bugs in the universe's operating system, but features that demonstrate its sophisticated error correction mechanisms. As you contemplate this, imagine you're watching a game of billiards where every shot is perfect, where every angle is calculated, where the balls dance in patterns that seem choreographed. Now imagine one pocket leads to the past. The game becomes infinitely more complex, but perhaps not impossible. The players would need to account not just for where balls are going, but where they've been. Not just for current collisions, but for future past interactions. This is what Polchinski's paradox teaches us. Time travel doesn't necessarily break physics, but might reveal physics we haven't yet understood. The simple billiard ball, following its simple trajectory, becomes a probe into the deepest mysteries of time, causality, and existence. Its path across the table traces questions about free will, determinism, and the nature of physical law itself. The paradox also suggests something beautiful about constraint and creativity. When the ball must create a self-consistent loop, it doesn't have infinite freedom. But within the constraints, infinite solutions exist. It's like a sonnet, 14 lines, specific meter, particular rhyme scheme, yet infinite poems are possible. The universe might be similarly constrained by consistency, yet infinitely creative in its solutions. Consider how this applies beyond billiard balls. Every particle in the universe follows trajectories through space-time. If time travel is possible, each particle must find its self-consistent path, creating a cosmic dance of incredible complexity. Yet physics suggests this dance might naturally organize itself, each particle finding its place in the grand pattern without paradox or contradiction. The billiard ball rolls toward the pocket, toward its journey through time, toward its meeting with itself. Will it deflect itself away, creating paradox? Will it graze itself gently, ensuring consistency? Or will quantum mechanics blur its trajectory into all possibilities simultaneously, letting the universe choose the path that maintains the integrity of cause and effect? Polchinski's paradox strips time travel to its mathematical bones, removing human agency and emotion to reveal the pure logical structure beneath. And what it reveals is both troubling and beautiful. A universe that might permit loops in time, but not loops in logic, that allows effects to precede causes, but not contradictions to exist, that bends the rules of sequence while maintaining the deeper law of consistency. In the end, the billiard ball completes its journey, emerging in the past to meet itself, creating the very trajectory that led to its time travel. The paradox resolves not through divine intervention or conscious choice, but through the simple elegance of physical law finding its own solution. The ball doesn't know it's avoiding paradox. It simply rolls, following forces and trajectories, tracing out the only path that can exist, the one that does exist. The table is quiet now, the ball at rest, but the implications of its journey continue to ripple through our understanding of time, causality, and the deep structure of reality. Polchinski's paradox reminds us that even the simplest objects, following the simplest laws, can reveal complexities that challenge our most fundamental assumptions about how the universe works. And perhaps that's the most profound paradox of all, that simplicity itself can generate such beautiful complexity when time curves back upon itself. The Time Traveler's Meeting Paradox. Picture a small cafe in Vienna, November 15th, 2055. It's unremarkable except for one thing. Today, 17 people will walk through its doors, order coffee, and sit at various tables, each trying not to stare at the others. They range in age from 25 to 70, but they all share the same scar on their left hand, the same way of stirring sugar counterclockwise, the same nervous habit of tapping their ring finger twice before lifting their cup. They are all the same person, travelers from different points along one timeline, and they've all come here for the same reason. They remember being here, meeting themselves, on this exact date. The youngest version, let's call them Riley 25, sits in the corner, overwhelmed. They invented time travel just yesterday, and their first test brought them here, to this mandatory appointment with their future selves. Riley 30 watches them with sympathy, remembering that confusion. Riley 40 makes notes in a journal, documenting what they recall from when they were Riley 30, trying to spot differences, discrepancies, changes in the timeline. Riley 60 seems tired, having made this journey many times, knowing they still have years of returns ahead. And eldest Riley 70 sits by the window, serene, knowing this is their last visit to this temporal crossroads. This is the time traveler's meeting paradox, perhaps the strangest of all temporal puzzles, because it multiplies the paradoxes by the number of selves present. Each version must be here because they remember being here. But who organized the first meeting? If Riley 25 is here because they remember being here as Riley 30, and Riley 30 is here because they remember being here as Riley 40, the chain of memory curves back on itself like an Ouroboros swallowing its own tail. The paradox deepens when you consider what they might discuss. Riley 25 wants to know about the future, but anything the older versions say will change that future. Riley 40 might warn about a mistake that Riley 35 is about to make, but if the warning is heeded, then Riley 40 never experienced the mistake, so how can they warn about it? Each conversation threatens to unravel the timeline that brought them all here. I imagine the conversations that must happen in that cafe. The older versions remember having these exact conversations when they were younger. They remember what they heard, what shocked them, what comforted them. Now, they must speak those same words, play their part in the temporal script. But do they have a choice? Can Riley 50 decide to say something different than what they remember hearing when they were Riley 25? And if they do, what happens to the 25 years of history between those 2 points? This paradox extends beyond the individual to encompass the entire nature of identity across time. Are these 17 people the same person or different people? They share memories up to Riley 25's present, but from there, their histories diverge. Riley 30 has lived 5 years that Riley 25 hasn't experienced yet. Those years have changed them, shaped them, perhaps fundamentally altered who they are. Yet they all identify as the same person, claim the same past, will live the same future. The philosopher Derek Parfit would have been fascinated by this scenario. He argued that personal identity is not what matters. What matters is psychological continuity and connectedness. These 17 Rileys are psychologically continuous, each remembering being the younger versions. But they're also distinct, each shaped by experiences the others haven't had yet or can't remember anymore. They are both one and many, same and different, united and divided by time itself. Consider the practical challenges of such a meeting. Who speaks first? Do they take turns by age? Does Riley 70 have authority over the others by virtue of experience? Or does Riley 25 have special status as the version living in the present? If they vote on something, does each get one vote? Or are they collectively one person with one vote? The meeting becomes a microcosm of every philosophical puzzle about identity, democracy, and temporal authority. There's something particularly poignant about the middle-aged versions. Riley 45 sits between youth and age, remembering being young, anticipating being old, caught in the temporal middle. They look at Riley 25 with nostalgia, and at Riley 70 with trepidation. They are living proof to their younger self that life continues, and living proof to their older self that life was once different. They embody the journey that connects all 17 versions, but here's where the paradox becomes truly mind-bending. Each version's memories include this meeting, but from different perspectives. Riley 30 remembers being Riley 25 and meeting 16 older selves. But they also remember being Riley 26 and meeting 16 selves, being Riley 27 and meeting 16 selves, and so on. Their memory contains multiple versions of this same event, each from a slightly different age's perspective. The meeting isn't a single event, but a palimpsest of overlapping experiences. This creates what we might call temporal vertigo. Imagine trying to remember something that you've experienced from 17 different perspectives across 45 years. Which memory is the real one? The fresh, immediate experience of Riley 25? The fading, possibly distorted memory of Riley 70? Or some aggregate of all 17 viewpoints? The meeting exists not as a single moment, but as a smeared experience across decades of subjective time. The paradox becomes even stranger when we consider knowledge and information. Riley 25 knows only what they've lived through. Riley 70 knows the entire life story, but that knowledge is precisely what they cannot fully share. If Riley 70 tells Riley 25 everything that will happen, those events might not happen, which means Riley 70's knowledge would be false. But if it's false, why should Riley 25 believe anything they say? The meeting becomes an exercise in calibrated revelation, each version saying exactly enough to preserve the timeline while fulfilling their remembered role. Think about the emotional complexity of such a gathering. Riley 25 might be full of dreams and ambitions. Riley 35 knows which dreams failed, but hasn't given up hope. Riley 50 has made peace with disappointments, but found unexpected joys. Riley 65 looks back with acceptance and forward with uncertainty. Each version carries the emotional weight of their years, and all those emotions exist simultaneously in that small cafe. The meeting also raises questions about responsibility and regret. If Riley 40 deeply regrets a decision they made at 35, can they warn Riley 34? Should they? If they prevent their younger self's mistake, do they erase 5 years of growth and learning that came from that mistake? Every version becomes responsible not just for their own choices, but for maintaining the choices of all other versions. This connects to a deeper paradox about knowledge and experience. We often wish we could go back with the knowledge we have now, make better choices, avoid mistakes, but the knowledge comes from the mistakes. Riley 60's wisdom exists because of Riley 30's foolishness. To prevent the foolishness would be to prevent the wisdom, creating a kind of experiential paradox where learning prevents itself. Some physicists have proposed that such meetings might be impossible not because of logical paradox, but because of what they call the chronology protection conjecture. The universe might have mechanisms that prevent time travelers from meeting themselves, not through physical barriers, but through probability itself. Every attempt to arrange such a meeting might fail through increasingly unlikely coincidences, the universe conspiring to prevent temporal awkwardness. But let's imagine the meeting proceeds. They've all ordered their coffee, the same way they always order it, will order it, have ordered it. They begin to talk, carefully, each remembering this conversation from multiple angles. Riley 25 asks about love, and several versions exchange glances, knowing what's coming but unable to prevent it. Riley 40 asks about a decision they're facing, though they already know what they'll choose because Riley 41 is sitting right there, proof of the choice made. The conversation would be like a carefully choreographed dance where everyone knows the steps but must pretend to spontaneity. Each version would speak words they remember hearing, react with surprise they remember feeling, even though they also remember speaking those same words as an older version. It's performance and authenticity simultaneously, each Riley being genuinely themselves while playing a role in their own history. As the meeting progresses, subtle differences might emerge. Maybe Riley 55's coffee cup has a chip that Riley 54 doesn't remember. Maybe Riley 33 has a grey hair that appeared earlier than Riley 40 recalls. These tiny divergences could signal that the timeline isn't as fixed as they thought, that each journey through time creates small changes, that they're not all from exactly the same timeline, but from slightly different quantum branches. This possibility transforms the meeting from a paradox into something even stranger, a confluence of similar but distinct timelines. Each Riley would be meeting not their exact past and future selves, but close variations, versions whose lives diverged in tiny ways through the butterfly effects of time travel. The meeting becomes less about one person across time, and more about the multiverse of possibilities that spring from each moment. The emotional weight of such a realization would be staggering. Riley 25 isn't looking at their inevitable future, but at one possible future. Riley 70 isn't remembering their actual past, but one version of it. Each Riley becomes both more and less than they seemed, representatives of possibility rather than certainty. The meeting transforms from prophecy to probability, from fate to quantum superposition. As the afternoon wears on, the Rileys would need to confront the ultimate question: why are they really here? Is it just because they remember being here, a causal loop with no beginning? Or is there something deeper, some message that needs to be passed through time, some wisdom that can only be communicated through this strange temporal gathering? Perhaps the message is the meeting itself. By seeing themselves across time, each Riley gains perspective that no normal person could have. They see that life continues, that current problems pass, that new joys await, that aging brings both loss and wisdom. They see themselves with a compassion usually reserved for others, understanding their younger self's fears and their older self's regrets with equal empathy. The meeting might serve as a kind of temporal therapy, each version helping the others simply by existing. Riley 25's enthusiasm reminds the older versions of dreams they've forgotten. Riley 70's serenity shows the younger versions that peace is possible. The middle-aged Rileys bridge the gap, translating between the languages of youth and age, hope and experience. But there's also a profound loneliness in such a meeting. Each Riley is surrounded by themselves, yet entirely alone. They cannot truly connect with anyone here because everyone is them. They know every story, share every memory up to a point, will live every future being described. The meeting is simultaneously the most intimate and most isolated gathering possible. As the day grows late, the Rileys begin to leave. They must return to their own times, resume their lives, move toward or away from this moment. Riley 25 leaves first, overwhelmed, needing to process what they've seen. Riley 70 leaves last, taking one final look at their younger selves, perhaps wondering if this really is the last time, or if there's an Riley 75 somewhere who simply hasn't arrived yet. The cafe empties except for one figure, Riley 50, let's say, sitting alone, caught precisely in the middle of the journey. They remember being half the people who just left and will become the other half. They sit at the temporal center of their own existence, the fulcrum on which past and future balance. In this moment, they are most fully themselves, containing all the Rileys who were and will be. They finish their coffee, leave money on the table, probably the exact amount they remember leaving, will leave, have always left. They walk out into the Vienna evening, knowing they'll return, have returned, are returning even now in other versions of themselves. The meeting ends and continues, has always ended and never ended, a temporal knot that exists outside normal causation. The time traveler's meeting paradox shows us that identity itself might be more fluid than we imagine. We think of ourselves as continuous beings moving through time, but perhaps we're more like a series of connected moments, each complete in itself, creating the illusion of continuity through memory and anticipation. The meeting of 17 Rileys doesn't reveal one person, but 17 people who share a special relationship, connected by memory and destiny, but distinct in their moment of existence. As you drift towards sleep, consider this. Even without time travel, you meet your past and future selves every night in memory and imagination. You recall who you were, envision who you'll be, hold conversations across time in the theater of your mind. The child you were, the elder you might become, they're all present in this moment, meeting in the cafe of consciousness, sharing the strange burden and gift of being you. Tomorrow, you'll wake up one day older, having traveled through time at the standard rate of 1 second per second. You'll be slightly different than you are now, shaped by the dreams you're about to have, the rest your body is taking, the countless small changes that accumulate with each passing moment. You are already in a constant meeting with your past and future selves, negotiating identity across the strange territory of time. The Rileys in their Vienna cafe are just an extreme version of what we all experience. The paradox of being both continuous and changing, same and different, one person and many people spread across time. They show us that identity isn't a thing, but a process. Not a noun, but a verb. Not a being, but a becoming that never quite arrives at a final destination. The cafe in Vienna waits, November 15th, 2055, for a meeting that must happen because it has happened, will happen, is happening right now in the eternal present of a story that tells itself. 17 people who are one person who is 17 people. A paradox that multiplies with each telling, each remembering, each return to that necessary, impossible gathering of selves across time. The information loop paradox. A historian in 2140 discovers something extraordinary in the archives, a detailed account of a conversation that hasn't happened yet. According to the document, tomorrow at 3:47 p.m., she will discuss the origins of the Third Renaissance with a stranger in the university library. The transcript is perfect. Every word, every pause, even noting when she'll knock over her coffee cup at 4:13. Disturbed but curious, she goes to the library at the appointed time. The stranger appears exactly on schedule. They have the conversation, word for word as written, including her futile attempts to deviate from the script. She knocks over the coffee at 4:13. The stranger leaves at 4:25, just as documented. Later, she discovers that she herself will travel back in time in 30 years and place this document in the archives. The conversation was predetermined because she read about it, and she read about it because she will document it. But where did the information originally come from? Who first knew what would be said? This is the information loop paradox, perhaps the most subtle and profound of all temporal mysteries. Unlike physical objects that age or decay, information seems capable of existing in perfect closed loops through time, self-creating and self-sustaining, neither generated nor destroyed but simply existing, hanging in the causal void like a message without an author. Information has peculiar properties that make it uniquely suited to temporal paradoxes. It has no mass, no physical substance that degrades with time. You can copy it perfectly without depleting the original. It can exist in countless forms: written words, magnetic patterns, neural connections, quantum states, while remaining essentially the same. When information travels through time, it carries no entropy debt, bears no wear from its journey. It arrives in the past as fresh as when it left the future. Consider what happens in our historian's case more carefully. The document contains not just words, but knowledge, historical analysis, linguistic patterns, conceptual frameworks that won't be developed for decades. This information shapes her thinking, influences her research, becomes part of the intellectual foundation that will eventually lead her to write the very document she read. The ideas create themselves through a temporal loop that has no beginning, no moment of genuine creation or discovery. I think about this whenever I encounter a truly original idea. Where do insights come from? Sometimes they seem to arrive fully formed, as if plucked from some realm beyond normal thought. Mathematicians describe theorems appearing in dreams. Scientists report sudden intuitions that solve problems they've struggled with for years. Artists speak of being channels for creativity that flows through them rather than from them. What if some of these inspirations are information loops, knowledge that exists because it will exist, ideas that create themselves through the strange mechanics of time? The information loop paradox becomes even stranger when you consider that information isn't passive, it acts. The historian reads the document and it changes her behavior. She goes to the library because the document says she will. She has the conversation because she knows she must. The information doesn't just describe events, it causes them. It reaches out from its loop to shape reality, making itself true through the very act of being known. This connects to something physicists call the participatory universe, the idea that observation and information play fundamental roles in creating reality. In quantum mechanics, particles don't have definite properties until measured. The act of gaining information about a system changes that system. Perhaps information loops are an extreme version of this principle, where information doesn't just influence reality, but bootstraps itself into existence through closed causal chains. Think about DNA for a moment. It's information encoded in molecular form, instructions for building organisms that can read and replicate DNA. The information creates the machinery that processes the information. Life itself is a kind of information loop, though one that operates through reproduction rather than time travel. The temporal version might be no stranger than what's already happening in every living cell. The paradox deepens when you consider the nature of meaning. Information isn't just patterns. It requires interpretation, context, understanding. The words in the historian's document only have meaning because she can read them, but she can only read them because her culture developed language, writing, the specific concepts being discussed. The information loop must include not just the data, but the entire framework for understanding it. The loop creates its own context, its own conditions for meaningfulness. Let me share a thought experiment that haunts me. Imagine you receive a message from your future self containing instructions for building a device. The message says this device will revolutionize human civilization, end suffering, unlock the secrets of the universe. You build it, and it works exactly as described. Years later, you realize you must send the instructions back to your younger self to complete the loop. But you never actually invented anything. You just followed instructions that came from nowhere, that exist only because they exist. Are you an inventor or merely a conduit for information that invents itself? This scenario raises profound questions about creativity and free will. If the information for humanity's greatest achievements could come from temporal loops rather than human ingenuity, what does that say about progress, about innovation, about the nature of discovery itself? Perhaps every breakthrough is just information finally finding the right loop to manifest itself through. The information loop paradox also challenges our understanding of truth. We usually think something is true because it corresponds to reality. But in these loops, information becomes true by making itself true. The historian's document is accurate because reading it causes the events it describes. Truth becomes not a relationship between statements and facts, but a self-fulfilling prophecy that validates itself through circular causation. Consider how this might apply to larger scales. What if entire scientific theories, philosophical systems, even religions, are information loops? They exist because they will inspire someone to travel back and introduce them at the right moment in history. The ideas spread, develop, eventually lead to time travel, which enables someone to ensure the idea's own origins. Whole worldviews could bootstrap themselves into existence, creating their own theological or theoretical foundations through temporal recursion. The mathematician Kurt Gödel, who we mentioned earlier in connection with rotating universes, also proved something remarkable about formal systems. Any sufficiently complex logical system contains statements that cannot be proven within that system. These are true but unprovable, existing in a kind of logical loop where their truth depends on factors outside the system. Perhaps temporal information loops are the universe's way of manifesting Gödel's incompleteness. Truths that exist without derivation, facts without foundations. There's something eerily similar to how consciousness works. Your thoughts are aware of themselves, creating loops of self-reference. You think about thinking, know that you know, remember remembering. Consciousness might be nothing more than information loops in the brain, patterns that observe themselves, and in observing, create the self that observes. The temporal version might be consciousness extended through time, rather than just through neural networks. But the information loop paradox faces a unique challenge that other temporal paradoxes don't. The problem of error. Information can be corrupted, miscopied, misunderstood. Even in our historian's case, what if she makes a transcription error when creating the document? What if the ink fades before she finds it? What if she misreads a word? Any error would break the loop or create a different loop, propagating changes that might amplify through iteration. This is where quantum mechanics might offer a resolution. In quantum computing, there's a concept called error correction through redundancy. Information is encoded across multiple quantum states so that errors can be detected and corrected. Perhaps temporal information loops have a similar mechanism, existing across multiple parallel timelines or quantum branches, with only the self-consistent version surviving. The universe might perform a kind of cosmic error checking, ensuring only stable information loops can exist. The paradox becomes even more complex when you consider translation and interpretation. The historian's document is in a language, but languages evolve. Words change meaning, contexts shift, cultural references become obscure. For the loop to work, The information must be not just preserved, but comprehensible across time. This suggests that successful information loops might be limited to mathematical or logical truths that transcend linguistic change, or they must include their own interpretive framework, becoming self-contained semantic universes. Think about the implications for communication. Every message you send is interpreted through the receiver's context, their knowledge, their assumptions. In a temporal information loop, you might be both sender and receiver, but separated by years of experience. The message you send to your past self must account for who you were, not who you are. The loop must include not just information, but empathy, understanding, a bridge across the temporal gulf between different versions of yourself. This brings us to a fascinating possibility. What if all information is already in loops, but we only perceive it linearly? What if every idea, every discovery, every creative act is part of vast temporal circuits that we can't see from our limited perspective? We think we're creating something new, but we're actually just completing loops that have always existed in the block universe of space-time. The physicist John Wheeler proposed something similar with his concept of it from bit, the idea that reality emerges from information. But if information can exist in temporal loops, then reality itself might be self-creating, bootstrapping itself into existence through closed chains of causation that have no beginning or end. The universe becomes a vast information loop, computing itself into being through its own self-consistency. As our historian sits in her study, contemplating the document she must someday place in the archives, she faces a terrible question. Does she have a choice? Can she decide not to complete the loop? If she destroys the document instead of preserving it, what happens to the 30 years of her life that depended on reading it? The information loop seems to trap her in inevitability, making her a prisoner of knowledge that exists outside normal causation. But perhaps there's freedom within the constraint. The document describes what she'll say, but not what she'll think. It records her words, but not her feelings. The information loop constrains certain aspects of reality while leaving others free. She might be bound to speak certain words at certain times, but the meaning she finds in them, the inner experience of speaking them, this remains hers to determine. This suggests a profound truth about information and experience. Information can be looped, copied, transmitted through time, but experience remains unique to each moment. The historian reading the document and the historian writing it decades later are the same person processing the same information, but their experiences are different, separated by 30 years of life. The loop preserves data, but not qualia, facts, but not feelings. Consider how this applies to memory. When you remember something, you're not retrieving stored information, but reconstructing experience from informational fragments. Each remembering is a new experience, even of the same information. If memories could travel through time in perfect loops, they would arrive as information to be experienced anew, not as experiences themselves. The loop would preserve what happened, but not what it felt like. The information loop paradox also raises questions about authorship and ownership. Who owns ideas that create themselves? Who deserves credit for discoveries that have no discoverer? If a temporal loop brings Shakespeare's plays into existence, is Shakespeare still the author, or is he merely the scribe for information that authored itself? The loop disregards our notions of intellectual property, creativity, and human achievement. As you approach sleep, consider this. Every thought you have changes your brain, creating patterns that influence your future thoughts. Your mind is already full of information loops, ideas that reinforce themselves, beliefs that create evidence for themselves, expectations that fulfill themselves. The temporal version of the paradox might be no stranger than what's already happening in the feedback loops of consciousness. Tomorrow, you might have an idea that seems to come from nowhere. A solution to a problem, a creative inspiration, a sudden understanding. Where does it really come from? Is it emerging from the unconscious processing of your brain? Or could it be information completing a loop, arriving from a future where you'll share this idea with someone who'll ensure it reaches you in the past. The paradox suggests that origin might be the wrong question. Some information might simply exist, neither created nor destroyed, only discovered by those who complete its loops through time. The historian finally understands. The document isn't a trap, but a gift. Information that exists to prove that some things transcend normal causation. She'll preserve it in the archives, ensuring her younger self finds it, not because she must, but because she chooses to complete the loop. The information doesn't control her, she partners with it, helping it achieve the existence it has always had, will always have, is having right now in the eternal present of a loop that needs no beginning because it has no end. The information loop paradox whispers that knowledge might be more fundamental than we imagine, that ideas might have their own existence independent of the minds that think them, that creativity might be less about generating something new and more about discovering what has always existed in the space of possible thoughts. It suggests that we are not just thinkers, but mediums through which information flows, completing circuits that span across time, participants in a vast exchange of knowledge that transcends the linear progression from ignorance to understanding. In the quiet before sleep, you might sense them, the loops of information flowing through time, ideas seeking minds to think them, knowledge waiting to be discovered by those who will ensure it was always there to be found. The paradox isn't a problem to be solved, but a glimpse into the deeper structure of reality, where information dances with itself across time, creating meaning through eternal recursion. Existing because it exists, true because it makes itself true, a message that is its own author, a question that is its own answer, a loop that completes itself through you. The closed time-like curve paradox. In the mathematics department at Princeton, 1949, a brilliant logician sits at his desk, pencil moving across paper in strange, looping calculations. Kurt Gödel, Einstein's walking companion and closest intellectual friend, has discovered something that disturbs even him. His equations describe a universe that rotates, and in this rotating universe, space and time twist around each other like candy cane stripes. Follow one of these stripes far enough, and you arrive at your own past. Not through a machine, not through a wormhole, but simply by traveling through space in a particular direction. Time curves back on itself as naturally as the surface of Earth curves around to meet itself. These paths, these closed time-like curves, don't break physics. They emerge from Einstein's own equations, as valid as any other solution, as real as gravity itself. The closed time-like curve paradox isn't about the contradictions time travel might create. It's about something more unsettling, that time travel might be woven into the very geometry of space-time, that the universe might be structured in ways that make chronology not a law, but a local convention, like saying up on a sphere that has no true up or down. The paradox is that such curves can exist at all, that the mathematics we use to describe reality permits, even requires, the possibility of effects preceding causes. Imagine you're an ant walking on a cylinder. If you walk straight ahead, parallel to the cylinder's axis, you move forward in what seems like a straight line. But if you walk at an angle, spiraling around the cylinder, you might eventually arrive back where you started. You've traveled in what seemed like a straight path through your local space, but the global geometry brought you back to your beginning. Closed time-like curves work similarly, except the cylinder is space-time itself, and the journey that returns you to your starting point takes you through time as well as space. Gödel's rotating universe was the first example, but physicists have since found closed time-like curves in many solutions to Einstein's equations, near rotating black holes, in the vicinity of infinite rotating cylinders, inside traversable wormholes, around cosmic strings. Wherever space-time gets twisted enough, these loops appear. They're not errors or approximations. They're what the mathematics says should exist given certain conditions. The universe's operating system includes time travel in its basic code. But here's what makes this truly strange. On a closed time-like curve, there is no universal before or after. Events don't have a fixed chronological order. What counts as past or future depends on your path through space-time. Two observers might disagree not just about when something happened, but about whether it has happened yet or happened already. Time becomes relative not just in its rate, as Einstein showed, but in its very direction. Think about what this means for causation. We understand cause and effect through temporal sequence. First the cause, then the effect. But on a closed time-like curve, every event is both before and after every other event. The match lights the fire, but the fire also lights the match. The chicken lays the egg that hatches the chicken that lays the egg. Causation becomes circular, or perhaps causation as we understand it simply stops making sense. I find myself thinking about a thought experiment called the Polchinski paradox, which we discussed earlier with billiard balls. But the closed time-like curve version is even purer. The ball doesn't need a time machine. It just follows a path through curved space-time that happens to loop back. No technology required, no intervention needed. The universe's geometry alone creates the paradox. It's like discovering that walking straight ahead in your city sometimes takes you backward through your own life. The mathematician and physicist Roger Penrose proposed something called the cosmic censorship hypothesis, suggesting that the universe might hide these problematic regions behind event horizons where they can't affect the outside world. But even if true, this doesn't eliminate closed time-like curves. It just quarantines them. They still exist in the mathematics, still represent valid solutions to the equations that govern reality. The universe permits them, even if it hides them. What disturbs physicists most about closed time-like curves isn't their paradoxical nature, but their naturalness. They emerge from general relativity as easily as elliptical orbits emerge from Newton's laws. You don't need exotic matter or impossible energies. You just need space-time curved in particular ways, and the universe seems perfectly capable of creating such curvatures. Near the Big Bang, when the entire universe was dense and violently dynamic, closed time-like curves might have been common. This raises a startling possibility. What if the early universe was full of closed time-like curves? What if causation as we know it only emerged later, as the universe expanded and cooled? The orderly progression from cause to effect that we take for granted might be a recent development, cosmically speaking. In the beginning, past and future might have been thoroughly mixed. Events causing themselves, effects preceding causes, time tied in knots that only gradually straightened out. Consider what this means for the origin of the universe itself. We ask what caused the Big Bang, but if the early universe contained closed time-like curves, it might have caused itself. The universe might be the ultimate bootstrap paradox, creating itself through loops in space-time that existed when time itself was still forming. The question, what came before, becomes meaningless if before didn't exist as a coherent concept until the universe had already begun. The physicist Stephen Hawking proposed something called the chronology protection conjecture, arguing that the laws of physics must somehow prevent closed time-like curves from forming, or at least prevent them from creating paradoxes. But this remains a conjecture, unproven and perhaps unprovable. The universe might protect chronology, or it might not care about our paradoxes at all. In quantum mechanics, closed time-like curves become even stranger. A quantum particle traveling along such a curve doesn't have a definite path, but exists in a superposition of all possible paths. The particle might interact with itself, creating what physicists call a quantum time loop. These loops don't create paradoxes in the classical sense, but instead generate what David Deutsch called fixed point solutions, self-consistent quantum states that remain unchanged despite the temporal loop. Imagine a quantum computer with access to a closed time-like curve. It could solve problems that are impossible for normal quantum computers, finding solutions by trying all possibilities simultaneously across time as well as across quantum states. The closed time-like curve becomes a computational resource, turning temporal paradox into processing power. The universe might use such curves to compute its own existence, solving the equations that govern reality through temporal as well as quantum superposition. But there's something even more profound to consider. If closed time-like curves exist, then the distinction between past, present, and future might be an artifact of our limited perspective. We experience time linearly because we follow time-like paths that don't close, but the universe itself might be thoroughly temporal, with all moments equally real and mutually accessible. What we call the flow of time might be just our trajectory through a static four-dimensional structure where past and future are directions like left and right. This connects to something called the block universe interpretation of relativity. In this view, space-time is a four-dimensional block where all events, past, present, and future, exist eternally. We experience this block sequentially, moment by moment, but the entire structure is already there. Closed time-like curves are just paths through this block that happen to loop back, like hiking trails that circle around to their starting point. The paradox deepens when you consider consciousness. We experience ourselves as continuous beings moving through time, but on a closed time-like curve, you could meet yourself, interact with yourself, even prevent your own existence. Which version is the real you? The one who remembers less because they're younger, or the one who remembers more because they're older? Or are both equally real, 2 points on a curve that happens to intersect itself? A thought experiment. You're traveling along a closed time-like curve, not knowing it. You live your life, make decisions, form memories. Eventually your path curves back and you encounter your younger self. But from your younger self's perspective, they're encountering their older self. Both of you are moving forward through your own subjective time, but those forward directions point toward each other's past. You're both cause and effect, both earlier and later, both the one who influences and the one who is influenced. The closed time-like curve paradox suggests that our entire conception of time might be wrong. We think of time as a river flowing from past to future, but perhaps it's more like an ocean, with currents that sometimes eddy and spiral, creating whirlpools where past and future mix. We happen to be riding a current that flows steadily forward, but other currents might flow backward or in circles. The paradox isn't that such curves can exist, but that we assumed they couldn't. In some interpretations of string theory, our universe is a four-dimensional membrane floating in a higher dimensional space. Closed time-like curves might be places where our membrane curves back and touches itself, creating shortcuts through time, just as a folded piece of paper creates shortcuts through space. From our perspective within the membrane, these look like temporal paradoxes. From outside, they might be no stranger than any other geometric feature. The physicist Lee Smolin has proposed that the laws of physics themselves might evolve through a kind of cosmic natural selection, with universes that create black holes spawning new universes with slightly different laws. If closed time-like curves can exist, they might play a role in this evolution, allowing information from future universes to influence past ones, creating feedback loops that guide the development of physical law itself. As you lie there in the darkness, consider this. Your future light cone, the region of space-time you can influence, extends forward from this moment. Your past light cone, the region that can influence you, extends backward. In normal space-time, these cones never intersect themselves. But near a closed time-like curve, your future light cone might curve around to intersect your past light cone. You could influence events that influence you, create causes that create themselves, participate in loops of causation that have no beginning or end. The mathematics allows it. General relativity permits it. Only our intuition rebels, insisting that time must flow in one direction, that causes must precede effects, that the past is fixed and the future is open. But intuition evolved in a region of space-time where closed time-like curves are rare or absent. We're like flatland beings trying to understand three-dimensional knots. The structure exists, but our perspective makes it seem paradoxical. Tomorrow, you'll wake and move forward through time in the ordinary way, following a time-like curve that doesn't close, at least not that you'll notice. But somewhere in the universe, perhaps near a rotating black hole, or in the quantum foam at the Planck scale, closed time-like curves might exist. Events might be causing themselves, effects preceding causes. The future creating the past that creates the future. The closed time-like curve paradox isn't just about time travel. It's about the nature of time itself, about whether chronology is fundamental or emergent, about whether the universe has a preferred direction in time, or whether all directions are equally valid. It suggests that paradox might not be a flaw in our thinking, but a feature of reality, that the universe might be stranger than we can imagine, that time itself might be a far more flexible and mysterious dimension than our everyday experience suggests. Gödel never published his thoughts on the philosophical implications of his rotating universe. He found the mathematics beautiful, but the consequences disturbing. Here was proof that time travel wasn't forbidden by physics, that the universe could tie time in knots. That chronology might be an illusion we impose on a reality that doesn't share our concern for cause and effect. He had used Einstein's own equations to show that Einstein's intuitions about time were incomplete. In the end, the closed time-like curve paradox leaves us with a choice. We can assume that something, quantum effects, cosmic censorship, chronology protection, prevents these curves from creating real paradoxes. Or we can accept that paradoxes might be part of reality's structure, that the universe might not be obligated to make sense to minds that evolved in a small corner of space-time, where time happens to flow in one direction. The curves loop through space-time, carrying travelers back to their own past, forward to their own future, around and around in endless spirals that respect the mathematics but violate our intuitions. They exist in the equations, these paths that make time circular, that turn chronology into topology, that transform paradox from impossibility to itinerary. Whether they exist in reality remains unknown, but their possibility haunts physics, reminding us that time might not be the simple, one-way street we navigate every day, but rather a complex manifold where past and future meet. Causation curves back on itself, and the impossible becomes inevitable through the simple geometry of space-time itself. The infinite causal regress paradox. A time traveler stands at the control panel of their machine, about to journey backward 100 years. But wait. To arrive in the past, they must first travel to a moment halfway there, 50 years ago. But to reach that point, they must first arrive 25 years in the past, and to get there, 12.5 years. The journey fragments into infinite steps, each requiring infinite sub-steps, like Zeno's arrow that must traverse infinite halfway points to reach its target. How can the traveler complete infinite actions in finite time? Yet if they cannot, how does anyone travel through time at all, even at the normal rate of 1 second per second? This is the infinite causal regress paradox in time travel, where the very act of moving through time seems to require an infinite sequence of causes and effects, each depending on countless others, regressing endlessly into a causal abyss from which no action could ever emerge. It's not about changing the past or creating loops, but about whether temporal movement itself is logically possible when examined closely enough. Consider your own existence in this moment. You're here because of your past, the breakfast you ate, the sleep you had, the day you lived yesterday. But that day depended on the day before, which depended on the day before that, reaching back through your birth, your parents' meeting, the evolution of humanity, the formation of Earth, the Big Bang itself. Your presence in this moment seems to require an infinite chain of causes, stretching back eternally. How can an infinite sequence ever complete itself to produce this finite moment of now? The paradox becomes more acute with time travel because it makes the causal chains visible and problematic. A normal person existing through time can ignore the infinite regress. It's already happened after all. But a time traveler must actively create their path through time, and creating that path seems to require completing infinite tasks. It's like trying to write down all the decimal places of pi before you can circle a square, or counting to infinity before you can take a single step. I think about this whenever I consider the smallest units of time. Physicists speak of Planck time, about 10 or 43 seconds, possibly the shortest meaningful duration in our universe. But even Planck time can be subdivided mathematically. Between any two moments, no matter how close, infinite instants exist. The time traveler must somehow traverse these infinite instants, experience infinite moments, create infinite causal connections, all to move from now to then. This connects to an ancient paradox from Zeno of Elea about Achilles and the tortoise. Achilles can never catch a tortoise with a head start, because first he must reach where the tortoise began, but by then the tortoise has moved forward. He must then reach that new position, but the tortoise has moved again. The gap shrinks but never disappears, creating infinite tasks that seemingly prevent motion itself. We know Achilles does catch the tortoise, just as we know time travelers in our thought experiments do reach the past. But how? The mathematician Georg Cantor gave us ways to think about infinity that might help. He showed that some infinities are larger than others, that infinite sets can be completed and manipulated, that the infinite isn't necessarily paradoxical. Perhaps the infinite causal steps in time travel are like the infinite points on a line, uncountably many, yet traversable. You don't need to touch each point individually to move across the line. You simply move, and in moving, you traverse them all simultaneously. But time travel adds a twist that simple motion doesn't have: intentionality and causation. Each moment of the journey backward through time seems to require a decision, an action, a cause producing an effect. The traveler must somehow cause themselves to exist at each intermediate point, maintaining their coherence as they slide against time's normal flow. It's not passive like falling, but active like climbing, and climbing infinite steps seems impossible, even if falling past infinite points is not. Think about what happens to causation itself during time travel. In normal time, causes precede effects in neat sequence. But a traveler moving backward experiences effects before causes, sees outcomes before origins, arrives at destinations before departing. Their personal causation runs counter to universal causation, creating a kind of causal friction. Every moment of backward travel must somehow overcome the forward pressure of causality itself, like swimming upstream in a river of consequence. The paradox deepens when you consider that the time traveler must maintain their own causal coherence while violating universal causation. Their atoms must stay organized, their memories intact, their consciousness continuous, even as they move through a reversal of entropy where everything else tends toward disorder. They must somehow be causally isolated from the backward flowing time while still interacting with it enough to exist within it. It's like being wet while repelling water, present while absent, causing while uncaused. This brings us to something philosophers call the grounding problem. Every fact seems to need grounding in some deeper fact. Every cause requires a prior cause. Every explanation demands further explanation. Time travel makes this usually hidden regress visible and problematic. The traveler's arrival in the past needs to be grounded in their departure from the future, but that departure needs grounding in their decision to travel, which needs grounding in their existence, which needs grounding in the history they're about to change. The grounding curves back on itself, creating not just circles, but infinite spirals of causation. Some physicists suggest that time travel might require what they call a preferred foliation of spacetime, a unique way of slicing four-dimensional spacetime into three-dimensional moments. The traveler would move between these slices rather than through the continuous manifold of spacetime. This would reduce the infinite regress to a finite, though perhaps very large number of discrete jumps. Time travel becomes digital rather than analog, quantum rather than continuous. But this solution raises its own questions. Who or what determines the preferred foliation? Why should space-time come pre-sliced in a way convenient for time travelers? It seems to require exactly the kind of absolute time that Einstein's relativity eliminated. The cure might be worse than the disease, solving infinite regress by reintroducing concepts physics has abandoned. Consider another approach. Perhaps the infinite regress is real but not problematic. In calculus, we routinely sum infinite series to get finite results. The infinite geometric series 1,2 plus 1,4 plus 1,8 plus 1.16 equals exactly 1. Maybe the infinite causal steps in time travel similarly sum to a finite journey. Each step might be infinitesimally small, contributing an infinitesimal portion to the total travel, all adding up to one complete trip through time. This mathematical resolution is elegant, but doesn't address the philosophical problem. Even if infinite causes can produce finite effects, how do they do so? What makes the series converge rather than diverge? What ensures that the infinite steps of time travel add up to arrival in the past, rather than eternal suspension between moments? The mathematics might work, but the metaphysics remains mysterious. The paradox becomes even more complex when you consider the direction of explanation. We normally explain the present through the past. This happened because that happened earlier. But in time travel, especially backward time travel, the explanation might run the other way. The traveler arrives in the past because they will depart from the future. The cause comes after the effect. The explanation follows what it explains. This reversal doesn't eliminate infinite regress, but doubles it. Now we have infinite causes stretching in both temporal directions. A thought experiment illuminates this. Imagine two time travelers, one going backward, one forward, passing each other in the year 1850. Each sees the other, moving the wrong direction through time. Which one's causation is correct? From the backward traveler's perspective, the forward traveler is reversing cause and effect. From the forward traveler's view, it's the backward traveler who has causation confused. There's no absolute frame to determine who's right. Causation itself becomes relative, and with it, the entire structure of explanation and grounding that we use to understand reality. The infinite regress paradox also appears in the information carried by the time traveler. They bring knowledge from the future, but that knowledge was gained through a causal process that hasn't happened yet from the past perspective. The information exists without its causal history, like a book without an author, a message without a sender. The traveler's memories are effects without causes, at least without causes that exist in the timeline they've entered. This connects to something in quantum mechanics called the measurement problem. A quantum system exists in superposition until measured, at which point it collapses to a definite state. But what counts as measurement? Does the measuring device need to be measured? Does that measurement need measurement? The regress seems infinite, yet somehow measurements happen, superpositions collapse, reality crystallizes from possibility. Perhaps time travel involves a similar mystery, infinite regresses that somehow resolve into finite journeys. Think about consciousness itself as a form of time travel. Your awareness moves from moment to moment, carrying memories of the past and anticipations of the future. But how does consciousness move through time? What causes you to be conscious now rather than then? The question leads to an infinite regress. You're conscious now because you were conscious a moment ago, but that requires explanation too, spiraling back to when? Your first moment of consciousness. But what caused that? The regress has no satisfactory terminus. The philosopher Immanuel Kant argued that infinite causal regress proves that time must have a beginning, a first cause that needs no prior cause. But time travel seems to allow effects to be their own causes, events to explain themselves, causal chains to form closed loops that need no external grounding. The infinite regress might not need to terminate in a first cause, but could curve back on itself, creating finite loops from infinite sequences. As you drift towards sleep, consider the infinite regress of your own thoughts. Each thought seems caused by the previous thought, reaching back to where? When did the chain of thinking begin? How did the first thought arise from non-thought? And if you could travel backward through your stream of consciousness, would you find a beginning, or just an infinite regression of awareness emerging from itself? The infinite causal regress paradox in time travel might be telling us something profound about the nature of causation itself. Perhaps causation isn't fundamental, but emergent, arising from patterns in space-time rather than governing them. Perhaps the infinite regress is always there, hidden beneath our everyday experience, and time travel just makes it visible. Perhaps trying to ground each moment in previous moments is the wrong approach entirely. Maybe moments ground themselves, exist independently, connect through correlation rather than causation. Tomorrow, you'll wake and continue your journey through time at the conventional rate. But that journey involves the same infinite regress as any time travel. Between now and tomorrow morning, you must traverse infinite moments, complete infinite transitions, sustain infinite causal connections. Yet you will wake tomorrow, the infinite somehow summed into finite, the paradox resolved through the simple act of persistence. The time traveler at their control panel faces the same mystery magnified. To reach the past, they must complete an infinite journey in finite time, create infinite causes producing finite effects, maintain coherence across infinite discontinuities. It seems impossible, yet in our thought experiments, they succeed. They arrive in the past, infinite regress notwithstanding, paradox dissolved in the act of arrival. Perhaps that's the deepest lesson of the infinite causal regress paradox, that reality doesn't wait for philosophical problems to be solved before proceeding. Motion happens despite Zeno's paradoxes. Consciousness exists despite explanatory gaps. And in universes where time travel is possible, travelers reach their destinations despite infinite causal regresses. The paradox doesn't prevent the journey. It just reminds us that even the simplest acts, when examined closely enough, reveal infinite depths. The regress continues, cause before cause before cause, explanation beneath explanation beneath explanation, an infinite excavation that never reaches bedrock because there is no bedrock. Only more depth, more causation, more steps in a journey that somehow completes itself despite having no first step, no prime mover, no ultimate ground. The traveler moves through time not by solving the infinite regress, but by embodying it, becoming themselves an infinite sequence collapsed into finite form, a paradox resolved through existence rather than logic, a question answered by being asked. In the end, the infinite causal regress paradox leaves us not with impossibility, but with mystery. It shows us that our everyday experience of cause and effect, of temporal sequence, of grounded explanation, might be a surface simplification of something far deeper and stranger. Time travel doesn't create the infinite regress. It reveals it, forces us to confront the groundlessness that was always there, hidden beneath our assumptions about how one moment becomes the next. The traveler presses the button, begins their journey, traverses infinite instants in finite time. They arrive in the past, carrying with them all the paradoxes of causation, all the infinite regresses of explanation, all the mysteries of how moments connect across the strange territory of time. They are proof that infinite sequences can converge, that paradoxes can be lived even if not resolved, that the impossible recession of cause and effect doesn't prevent effect and cause, that reality transcends the logical problems it creates. The grandfather paradox. The year is 1905, and somewhere in Austria, a young man sits at a cafe, sketching in his notebook. He dreams of becoming an artist, unaware that history will remember him for something far darker. Now imagine you could travel back to that moment, knowing what this young Adolf Hitler would become. You could prevent the Holocaust, World War II, the deaths of millions. All it would take is one action, one moment of intervention. But here's where our story takes a curious turn, because the moment you succeed, the very reason for your journey disappears. If Hitler never rises to power, you never grow up in a world scarred by his actions, never develop the desire to go back and stop him. So how could you have traveled back in the first place? This is the grandfather paradox in one of its most morally charged forms, though the original version is both simpler and somehow more disturbing. Imagine instead that you travel back in time and accidentally or deliberately cause the death of your own grandfather before he meets your grandmother. The logic seems to unravel itself like a sweater with a loose thread. If your grandfather dies young, your parent is never born. If your parent is never born, neither are you. But if you were never born, who traveled back in time to cause your grandfather's death? The universe seems to tie itself in an impossible knot. Let me tell you about a conversation I once overheard between two physicists at a university conference. They were discussing this very paradox over coffee, and one of them said something that stuck with me. She said that time travel paradoxes are like trying to become your own parent, not biologically, but causally. You're trying to be the cause of the very circumstances that created you, or in this case, trying to eliminate the circumstances that led to your existence. It's like a snake swallowing its own tail, except the tail disappears the moment the snake succeeds. The grandfather paradox was first described in this form by science fiction writers in the 1940s and 50s, though philosophers had been grappling with similar temporal puzzles for much longer. The French writer René Barjavel wrote about it in his 1943 novel, Le Voyageur Imprudent, The Imprudent Traveller, where his protagonist faces exactly this dilemma. But the roots go deeper, back to ancient Greek philosophers who wondered about fate and free will, about whether the future could influence the past. Think about how we understand cause and effect in our daily lives. You plant a seed, and later a tree grows. You study for an exam, and consequently, you pass it. The cause always comes before the effect, as surely as Tuesday comes before Wednesday. This is so fundamental to how we experience reality that we rarely question it. But time travel seems to threaten this basic order. It's like trying to have Wednesday cause Tuesday, or having the tree plant its own seed. Some physicists have proposed fascinating solutions to this paradox. One is called the Novikov self-consistency principle, named after Russian physicist Igor Novikov. Imagine time as a river that has already carved its path from the mountains to the sea. You can travel up and down this river, but you cannot change its course because its course already includes your travels. In this view, if you went back in time to kill your grandfather, something would always prevent you. The gun would jam. You'd slip on a banana peel. You'd have a change of heart. The universe, in this interpretation, is like a completed jigsaw puzzle. Every piece, including your time travel, already fits perfectly into place. This brings us to a deeper question about the nature of time itself. We experience time as a flowing river, carrying us from past to future. But many physicists see time differently, as a dimension like space. Just as the entire length of a road exists simultaneously, even though you can only be at one point on it at any given moment, perhaps all moments in time exist simultaneously in what physicists call the block universe. Your birth, your death, this very moment as you listen to these words, all exist eternally in this four-dimensional space-time block.